And good morning, everyone. And we are here in the Karlsruhe Institute of Technology at NWERC 2025. The contest just started. My name is Alex. Here with me, Jonathan.
Good morning.
So yeah, what today looks like everybody dived into problems. We will have a long and exciting contest ahead of us. Uh, let's see how much time it would be needed for the contestants to find the easiest problems and implement them.
Yeah, we had a short discussion about that yesterday, how long we thought it's going to take. I think I said like 10 minutes. What do you think?
Um, Honestly, I think the first submission would be definitely probably earlier, like even earlier than that. There would be at least one team that would just implement something, but then it's tricky would they get accepted or not. Like I think we already see that some of the teams already started clicking buttons and writing some code. It could be just a template, however, it could already be a solution. Um, so yeah, uh, I think more than 3 minutes for sure, not like yesterday. Maybe less than strictly 10. I would bet on like 7.
Yeah, that sounds good. I mean, a bit faster than 10 minutes, I can agree on. Um,
We should have had the predictions contest between us to make it a bit more
mhm.
exciting.
True. I know that the jury always has a bit of a prediction contest. What percentage of teams solves each problem? I also know that there were some pretty hefty disagreements on the difficulty of some problems, but I think we will talk about that later.
Yeah, yeah, for sure. We have a mirror contest that is going on, so we wouldn't be discussing anything in the next some time, I would say so. And yeah, speaking about the predictions, so we've discussed about the time needed, but what do you think? What is your bet on the first place?
Um, well, might not sound very impartial of me, but I think our team from Karlsruhe University of Technology has very good chances. They beat the third place team from NWERC last year pretty well in the GCPC, and the first and second place team are not here anymore. But apart from that, I mean, there are the usual suspects. You have Oxford, Cambridge that can just always perform very well. Hasner-Plattner Institute also seems pretty strong. Um, Apart from that, I don't have any more universities memorized, but I think we also have a list somewhere.
Yeah, we definitely have the Saarland University and the University of Amsterdam teams that we had yesterday on our test session interviews. For everyone who is watching us, we have the recording of those interviews on this YouTube channel, so you can subscribe for the future events from the ICPC world and also rewatch the old streams and interviews. We will also probably be having some fun interviews today with maybe I don't know yet, but maybe we will have some coaches, some representatives of the sponsors. So stay tuned to hear more insights about the ICPC world, the future opportunities for our participants, and etc. Oh wow!
Yeah, the first accepted submission is already in. In?
So both of us were incorrect. It's like 4.5. You see in the
Oh.
corner of the screen that we have
Yeah,
in
I see.
front of us to make our life easier. Yeah, it's like 4.5 minutes. So we were not right. And it's the problem L. So it's basically the last one, which means that they just started reading it from the end. And also, by the way, it's the Unity team of the University of Cambridge. I would say that for me it would be my bold prediction then after this submission for sure that they can make it on the first place. I think they traditionally perform well. So yeah.
Mhm. Yeah, that actually sounds like a pretty sound prediction right now.
Yeah, 4 minutes. That's kind of impressive. We will discuss the problem a bit later. But anyways, I think 4 minutes even for this one. Yeah, that's decent.
Mm. Do I remember that correctly, that they were also the first to solve C in the practice session yesterday?
I think so. It might be the case. So they they really practice this.
Yeah, and as we talked about yesterday, if an easy problem is at the very start or very end of the problem set, it also helps to speed up the first accepted submission. Oh, I think Saarland also has.
But they got wrong answer.
Oh,
That's
I was
unfortunate.
just watching the scoreboard
Yeah.
here, and it's a bit slower. Okay, I should be looking there.
And one more submission. So we will probably see a yeah, runtime error for the University of Bergen. So we'll probably see a chain of submissions for the problem L. Yeah, as you said, like it seems like one of the easiest problems is in the end of the problem set. To be honest, I'm not usually liking that because like it sounds like you put it there because you wanted to make the order a bit random. But then when it's every time the last problem is one of the easiest one, it's not random anymore.
And I mean, there are 3 people on the team. It's very usual that at least one starts reading from the beginning and one starts reading from the end. So if you put one in the end, you kind of have to expect that there is someone on the team who starts reading from there.
We also have a couple of submissions from different universities for the problem E, which is kind of unexpected. We have it from the Eindhoven University of Technology and from the one more that I'm missing.
Oh, and we have first to solve on problem F from what university is this?
I think it's the Radboud University.
Radboud.
And the University of Liverpool were the second one to try problem E. Okay, so for E, it's kind of unexpected, I would say, to solve it from the start. For F, it's probably okay. I think those are the teams who started reading from the middle, and then it turned out that somebody just read the problem F faster than his teammate who is reading problem L.
In my team, we my teammates were reading from the start and from the end, and my job was to type the template, and then I would just pick up somewhere in the middle, depending on how far my teammates were already along, so that I would get about 1/3.
We also should mention that the Saarland University managed to solve the problem L with the second try, and actually we have an insight from our analysts that initially they had wrong answer on one of the samples. So it may be the case that they were hurrying up so much to solve the easy problem, so that now instead of just spending 1 more minute to test it, they got 20 more penalty minutes, which could cost them a lot in subsequent hours.
Yes, testing samples is really something you should do, and it's really worth the time.
Yeah, I think so. Especially in the end, like, oh, sorry, in the beginning, when the one submission, like, to just test something in just 1 minute, no, I think it's fair to try to test them. Yeah, by the way, for those who are watching us for the first time and who are newbies to the ICPC style contests, I think in total we have around 12 problems today. And as you can see, we have one laptop per team, so each team needs to optimize the time they spend typing code and thinking about the problems. And the goal is to solve as much as possible. And solve means to find the correct solution that fits in some memory and time limits that are set up in advance by the jury for each problem. And what make it also fun and a bit competitive and really similar to any kinds of sport when you have a limited time to do something is that teams also have the penalty time. So if 2 teams have same amount of problems solved, then their place is decided by the penalty time they have, which is the sum of the minutes, like exact amount of minutes when they got the accepted for each problem, plus 20 minutes for each incorrect submission, but only for problems that you solved.
I just remember because you asked what teams I think could win this. I also just remembered the University of Utrecht is pretty high up there for me. I think they're a bit of a wild card. Like maybe on average they're not that strong, but if they have a good day, from my experience, they could easily get a medal at World Finals. So I was just remembering that because I looked over there and saw that they had, in fact, a wrong answer submission. So let's hope that that wasn't a sign of what's to come, and they do, in fact, have a good day today.
Yeah, for sure. It would be nice if all the teams have the good day, because then they would show their best, and will see a lot of problems solved. By the way, while we were speaking, we had the first accepted for the problem D, which is, I don't remember what is it about, but it's probably okay to have it kind of quick. Yeah, we already have several accepted for it, and the first one to solve them were the Friedrich Alexander University. We actually discussed that it's a team that had participated in ICPC World Finals a lot years ago, if I remember correctly. Oh, no.
I think the university.
No, I messed it up.
Is it a
Oh,
different one?
No, oh no, they actually, this one. They
Ah,
participated, and they even had a seventh place in 2011. So maybe this year they also had a strong team that will qualify. So this is a good thing to be first to solve some of the easiest problems. And we also have an intelligence report that actually both initial submissions for the problem E were completely wrong. So this may be kind of a problem that could lead you to some wrong way. So let's hope that participants wouldn't be stuck for too long trying to crack it and understand what is wrong with their solution.
and just as a reminder, the D problem is the Dreamcatcher one. And I guess you could say that I think it's reasonable that for this problem you can come up with a solution that you can't quite prove, but you have a very strong intuition that your solution is right. So I can very much see that being solved in 9 minutes.
Yeah, totally agree. Totally agree. And by the way, we have incorrect submission on problem K from the Unity, the University of Cambridge, which is, I would say, a bit unexpected and unfortunate for them, because I do believe this problem also could be solved pretty quickly. But this, again, 20 minutes penalty is not nice. They basically lost all the advantage they had with being first to solve problem L.
Yeah, as we said, it might not be that that worth to spend a lot of time checking in the beginning, because you also get the time penalty basically on every other problem. But on the other hand, it's not nice to have such an easy problem and then have to go back and debug. I also know that from experience, if you have if you have trouble solving one of the easier problems, sometimes it's really stressful. Just not that nice for the flow of the contest, I guess.
Yeah, it really ruins your mood if you get some issues on the easiest problems, especially because you're losing time and you see that everybody is gaining like more and more solving second, third, and etc. And you're just stuck with something easy, even if you let your teammate to implement something and printed the code. But anyways, that time is ticking. So yeah. By the way, I also wanted to say that on the screen you could see that our teams have those nice balloons that are mostly purple, so I would assume that it's the color of the problem L. And for those who don't know, actually for each problem solved, the team received a nice balloon of the corresponding color. So closer to the end of the contest, we'll probably see a lot of teams having a lot of balloons all over the place.
I really think that is like in one of my favorite parts about ICPC, like the contest. apart from the competitive side, is also really fun. Like you get nice balloons. A lot of teams bring like a stuffed animal as a mascot, um, things like that. And also the funny team names are one of a personal favorite.
Yeah, I agree that that's the place where teams could be really creative. I think we discussed yesterday a bit of it, so yeah. By the way, we from the Hasaplaner Institute we have incorrect submission on problem E, so also one of the favorites I would say made incorrect assumption in this. Not the easiest problem I would say. It's definitely solvable, but probably is not something you need to work on in the I don't know the first hour.
Yeah, it's maybe a little bit the opposite of problem D, where in problem D you can just I probably guess something and it's reasonable, then it's probably right. And for E, you probably want to spend a bit more time um, really thinking what you want to do on the problem. We also have a new first solve, problem K from CUB.
Yeah, that's reasonable to also see this problem. Start University Bremen, yeah. Uh, it looks like they maybe started with it because they didn't try anything else, which is also I would say decent choice. Maybe to start with it could be fine. Maybe not the easiest way to start, not the L problem, but anyways, it's just the beginning of the contest, so I think they still have a lot of time and potential to come back in top.
Mhm. And just having a first solve to your name is also rather nice. Okay, we are seeing the first team on 3 problems now from Cambridge.
Yep, I think soon we will see 4 problems because we have 4 problems open. They all should be pretty straightforward for the top teams at least. So yeah, we also I think have groups of teams who opened either like K plus L or D plus F. So while they will be solving this, so yeah.
But I would say the teams we are seeing at the top are, for the most part, what we expect. We have Cambridge, we have the Infinite Loopers. Seems to be okay, isn't quite as far up as I thought. Do we see Oxford?
I think they maybe opens. Yeah. They have 2 problems. K plus L.
I see, yes.
Basically the only team right now with 2 problems with K
Mm.
plus L.
And Amsterdam is currently in 3rd place. That's the team we interviewed yesterday, right? It's all greedy to me.
Yep, exactly. And we received the problem set. So
Thank
now
you.
we have the printed statements, and probably we can start discussing problems. Just briefly, maybe we can, I don't know, just share the statement of the problem L with our viewers. It's the legend is related to kind of Christmas top sets of songs. So basically, you are given just some set of the top 10 lists of like some music charts, and you want to find the like very top artist, the top one. So it's basically the one which has the largest number of appearances in those lists. But in case there are multiple such artists, you like choose the one that has the most first positions. Then if if there is a tie again, you choose the one with the most second place position, and etc. And then in the end, if you haven't found anybody, you just output that it's a tie. I don't know. The thing about this problem is that while I was saying the statement, I've actually said the solution, because it's a kind of a problem that you can just
it tells you what to do and you just do it. It's more or less pure implementation, but there are still one or two things to think about. This might be the case where, I mean, we've seen it solved in 4 minutes, and you might want to spend a minute thinking about how exactly you implement this, because the time constraint is not really a problem here, but you just want to have like an easy and elegant to implement solution.
Yep, yeah, I agree. And also, like, it could be the case that somebody read it and like, okay, I need to like implement, I don't know, some dict, do something like that, and another guy told that, okay, but I read D and I just need like two or three lines of code maybe to implement my solution, and then you're like, okay, go on. So then it depends on the choice in the team, but yeah, overall this problem, I do believe it should be solvable by all of our teams, basically because it's not even harder than like yesterday's problems from the test session. I think it's kind of the same, just basic check of your programming and implementation skills. But the funny thing about this problem that we discussed at some moment, that what if the top artist name is Tai? No, I mean, it's just we could just have.
I was thinking what you were saying, like if it's a tie, you should output tie, but no, if the name of the top artist is literally tie,
Then you should also output tie, but
yes.
yeah, it probably doesn't matter. But
I mean, I guess the checker is implemented in a way where it's where it just compares the correct solution's output to the output given by the contestants. But that would be fun to know if the jury already did think of this case and even put that in somewhere.
yeah.
Okay, so we have our first team on 4 problems, and I think these are the only 4 problems that have been solved so far.
Yeah, exactly. So probably they would move to the harder problems now. So we'll soon see what is the next in terms of difficulty.
Do you have a guess what will happen next? What problem will be solved next?
Maybe A.
Maybe A. Oh, I remember this problem. But my guess right now is that J is going to be solved next.
Yeah, I think A or J, and this would again depend on what you read first. And like I could easily imagine that like one team started to read from the end, like one of your teammates is reading problems from the end and another one from the start, which basically means that if you implemented L and then K, if it was a single person in your team who is reading from the end, then this person only started reading J right now, while his teammate read A like 20 minutes ago and was thinking about it all the time. So I assume that probably because of that, just because of those timings, it could be the case that A would be also solved pretty soon. But yeah, I do agree that J is also the possible candidate. Also, we have an intel that right now teams are also trying to solve B, but all the solution are somehow greedy ideas that could pass, but no success yet. And yeah, we have the first to solve on problem E, by the way. So we both of us were completely wrong with the bets on the next problem.
Well, I guess we also could have seen that one coming. Most teams, or a lot of teams already tried that one, and it's again the university that already solved problem F first. So they have now two first solves to their name, which is actually already quite a lot.
Yeah, yeah, they may be not even looking at the scoreboard. It's like kind of a tactics that you can use if you are pretty confident in yourself until probably the some moment of the contest. But actually, right after them, the team Freezing Face also solved problem E. It's like the difference in the time is super tiny. But yeah, still the first to solve go to Redbound University. Oh, and the University of Cambridge also solved the problem E. So I'm actually thinking that the problem E is probably harder. It should be harder than A or J. At least that's my feeling. But maybe because some of the teams tried to solve it in the very, very beginning of the contest, the top teams were like, okay, let's check what is it about. They read the statement, and as it's as they know how to solve such kind of a problems, as they are one of the top teams, they just proceed solving it. And it could be a bit misleading for the teams that somewhere in the middle, because like if you follow in the scoreboard to see what you should solve next, I do believe the problem E could be misleading. I think it would be more helpful from the top teams if they would solve A or J and show a good sign. But yeah, we'll probably see a lot of incorrect submissions on E from the middle of the scoreboard. Yeah.
I mean, for the top teams, even the individual skill is so high that I guess they can, any single person in the team can just solve like 4, 5, 6, maybe more, probably more problems on their own. And only in the end, they really have to work together to figure out the last 2 or 3 problems. And that kind of leads to this effect where maybe the solving order is not optimal, just because someone opens the problem statement somewhere, reads a problem that they can solve, and they just do it.
Yeah, yeah, also could be the case. Yeah, it totally works, I think, in the beginning of the contest and in most of the times for the top teams. And the goal, yeah, because the goal basically to be as quick as possible, solving the easiest ones. Yeah, we now have the Unity solved all 5 opened problems and having only one first to solve on problem L. Yeah. There is still a potential for other teams to beat them in terms of time because they have a couple of incorrect submissions, while the second and third teams from Amsterdam and Utrecht are doing it in pretty clean way without any incorrect submissions.
Utrecht actually has one on L,
Oh yeah, I
but
missed it.
um, if they were to solve E right now, their penalty is still low enough that they would be first place.
Yeah, but it's E. I think if it was A or J, it could be the case. Yeah, we'll see. I think we're now reaching we're closer and closer to the moment of the contest where the new solutions would appear slower for the more complex problems, and we will see a lot of the teams just finishing those 5, I would say 5, 6 easiest problems, because right now, like, the team on the 17th place has only 2 correct solutions, while the first place has 5. So that basically means that a lot of teams having 2 or 3 right now would need, like, I don't know, half an hour or maybe an hour more to get the 5 problems solved.
I'm also already seeing a submission on problem J from the University of Bristol. So I think that's a good sign that this is actually the problem teams are looking at now, and that it might be solved next.
Yeah, and it's actually their first submission in the contest.
Oh,
It could be also a probability that they submitted incorrect problem and intended to send K or L, for example. But let's see. Maybe they really just accidentally read this problem first, and then it just, okay, we know how to solve it. Let's try. Right now on our screens, we're also seeing the team of JetBrains, the sponsor team, who are also working right now on the problem set. I think this team has like several world championships wins combined. Yeah, at least 3, I think, maybe even more, because Nias, who is sitting in the middle, is 2 times world champion. So it would be interesting to see how would they manage it. Do you think if there will be any sponsor team that would beat the top 1 team of the contest?
I'm not sure, but I think that Pavel, the one sitting on the right, almost, or maybe not, maybe not even almost, but did do that last year. Or maybe he almost did it and then stopped solving because he had other things to do. I'm not sure anymore. But now that they are a team of 3, I think they have very good chances to be the top team.
Yeah, I could agree. At the same time, like when you're not. Oh, by the way, we have a correct solution on problem A, solved by University of Cambridge, who hasn't yet solved the problem K. So they also have a great chance to have 5 problems soon, and they don't have E, by the way. So yeah.
Yes, it's the second team from Cambridge, and they are still missing 2 other problems, as you said, but now they have A.
Yeah, good for them. Good focus on slightly easier one K.
I just wanted to say also on the topic of sponsor teams, I guess the disadvantage for the sponsor teams is these teams that our regular participants just can take a lot of time to prepare for this and don't have too much other things to do, while the sponsor teams probably, you know, do a bit more of normal work, of regular work in their everyday.
Yeah, for sure. Like yesterday, I think teams were telling us that they were like preparing for 10, 20 hours a week for the NWERC, and obviously it's very important for them. It's a chance to qualify for the World Finals. And yeah, the sponsor teams, they just gathered together maybe today, didn't solve problems together for a while. So yeah, there is still a chance that some of their contestants would beat them. I think just because of this communication and synergy and practice together that could help, and it would really depend on the problem set. And yeah, in the meantime, we got the first to solve on problem J. So exactly as we discussed with you, if not for the problem, which one it was? Oh, we were correct. Was there anything else we were not expecting to be solved?
I don't think so. We were talking about A and J, and E just got solved.
Okay. Yep. That's good. Exactly as we expected. So probably we will soon have teams that even have 7 problems, because they would simply close everything that is opened right now, and it would be actually reasonable for the top teams that what the remaining problems are exactly the ones that you expect to remain for the remaining part of the contest. Oh yeah, we have an info that Jump Trading team, which is also sponsor teams, had 1 training before this. So yeah, they were even preparing for this to show their best.
I'm not quite sure if this message mean 1 training like per week or just 1 training total.
I hope that 1 training total, because 1 training per week with a team that had world champions is, yeah, could be not easy round for them, but definitely gives them an edge. Yeah.
Also, I think the team name of the team that solved problem J is a bit hard to read on stream. But they really took a long one. They probably pushed the character limit for team names. And it's, for those who know a bit of competitive programming and C++, it's just a definition of a lambda that does a DFS.
Yeah, so let's just call them Team DFS, I suppose. because otherwise we wouldn't be reading this code every time we mention them, as they're close to the top and currently in fifth. We would be probably doing it. By the way, I think we can take a look at the problem, maybe F, like when we have the possibility, and discuss the statement and maybe just briefly discuss what is it about. Yeah, I think the story of the problem is something about the splitting the bill to pay in the restaurant.
I think the restaurant in the problem statement. Oh, did the restaurant get removed from the problem statement? Okay, someone's nodding behind the screen. There was a specific restaurant, to my knowledge, named in the problem statement, and then Huawei invited all the KIT teams to that exact restaurant, and it was a bit of a strange coincidence. So I guess that's why it got taken out. No?
Anyways, like for the problem itself, the thing is that it's kind of the pure implementation again as the problem L. So basically, you have like 10 power to 5 elements of some array, that basically array of pairs of two integers of up to 1,000, which is not super huge, so you can easily take the sum of them and etc. And then the statement explains some restrictions that, oh, you should pick only one person among them who should pay for the full bill, and all the rest are giving him money and etc. So it's basically just the solution is kind of you should take the sum of all the numbers and then just iterate over them once more, check some simple condition, subtracting one number. So yeah, pretty straightforward. Most of the teams again should do it. However, it's slightly more difficult than problem L, so you need to think about it a bit with a piece of paper. But other than that, yeah, again, pure implementation, some simple addition, subtractions. Yeah.
Yeah, I guess you have to think about this a tiny bit more, because the trivial solution would be you iterate over each person that has to pay, and then you recalculate the entire sum. Because for the one person you pick, you have to take a different value, and you have to figure out that you don't have to recalculate the entire thing, but it's just a small change. But we were also talking yesterday a bit about problem B, because for B you actually need to know an algorithm, you need to know topo sort beforehand. This is still a problem where I think top teams should have seen this idea already a lot. But even if you're new here, you can figure this one out. It's not like you need to know some crazy algorithm for this problem.
Yeah, I think I would agree. I wasn't even thinking about it because I was like, okay, it's a trivial idea that you don't need to recalculate the full sum if the elements of the array are not changing, and you basically need the sum of all of them except one. That means you need to just calculate it once. But yeah, you're right that if someone has less experience in the composition, it probably could be it could take some time for them to come up with this idea. However, here we have the winners and leaders from the preliminary stages. So like most of the teams should had some good places in the preliminaries and made it well there. So I think that they should be able to do it. And by the way, while we are speaking, we have a first to solve on problem C. It's the team of the University of Cambridge who now have 6. And yeah, in the second place, we also have 6 problems already. The University of Cambridge as well. So 2 of their teams are in the top, fighting each other for the spot in the World Finals.
I mean, usually universities have like a first and a second team, and and the third team and so on in the order that they expect to place on the scoreboard. But I'm actually not quite sure which of these teams is, I guess, supposed to be the first and which one is the second team.
That's good question. I think if we look at their preliminary results, that Unity team was the first there, and this Barucho Pan, or how to read it, it was the second. So it's funny that they're switching right now.
I guess I would pronounce it bra open, like bra, like bro, and then kind of like file open, but you're not opening a file.
Yeah, okay, now I get it. It's also good for them because they have problem C and A, two first solves. They opened both of them, and I think C is not the most straightforward problem, like for sure. It's a graph theory. Here you definitely need to just know some theory and have some experience in solving those problems. I would say it's extremely hard to come up with anything correct here if you haven't solved any graph problem in your life before. So yeah, it's good for them that they realized how to do it before they solved problem E, actually, that is solved by like at least 6 teams, I suppose, right now, or 5. Yeah, 5 teams. But anyways, that means that soon they may have 7 problems, and then it becomes much more interesting, actually, because the remaining no, they don't have J as well. So J is also quite straightforward, and they could solve it as well. So even there is a room to have 8 problems solved in like slightly more than an hour, and then for the remaining 4 problems, they could spend the remaining 4 hours without solving all of them, actually.
Yeah, but it looks very good for them, like having 2 problems nobody else has, and just now just checking off the easy problems, I guess. I would feel quite confident in that position. But I mean, there are still very strong teams just below them. The other Unity team, the Utrecht team, the Amsterdam team.
Yeah, I agree. I think also they have pretty small penalty time because obviously this University of Cambridge, which are currently first and currently trying to solve problem E, and they succeeded, so they have 7. Everything with the first try. Yeah, with every minute it becomes harder and harder for other teams to catch them, but still, as we are too early in the contest, there is still some time, because also the most difficult problems could be so difficult for the teams that even if you are good, if you are fast, if you solved easier problems fast, that doesn't mean that there is no one who could catch you, who could solve even more problems, just because they may crack some of the hardest ones, like I, for example.
Yes, being fast and being able to solve difficult problems are 2 different skills. And just because you solve the easy problems fast in the beginning of the contest definitely doesn't mean that you will manage to do the difficult ones later. I think the University of Amsterdam even said yesterday that they have like one person who is speed solving in the beginning and another one who is basically from the beginning working on difficult problems. So maybe the University of Amsterdam can get one of the more difficult problems that Cambridge can't.
Yeah, totally agree. Exactly. We still have a bunch of teams which didn't solve anything, but a lot of them tried to solve something. It's a bit confusing to me that some of them are trying to solve like B, and that's the only problem that they tried, which is not probably the most obvious choice, or E. So hopefully they will look at the last problems in the problem set and switch to them, because I think they're like K, L, and even J are pretty solvable.
Yes, I think problem B is one. Um, So I was talking earlier about problems with heavy disagreements on the difficulty, and I was mainly thinking about problem B. Uh, by the way, we have a jury member behind the camera, and he's nodding along to to the statement. Yeah, so it's I guess it's a problem that looks very solvable, but might not be so. And I don't know if maybe some teams, especially newer teams, don't split up the problem set, but just decide, okay, we are going to work as a team from the beginning.
Yeah, and it's also the kind of problem that you like read it and agree that you feel like just based on the statement, usually something like this should be kind of solvable somehow. Then you start thinking, you can come up with tons of greedy ideas. And the trick is that if you don't probably as experienced with the competitions or just less cautious to details, you may just miss some corner case and then just be stuck in this infinite loop of submitting incorrect, greedy solutions, trying to understand what is wrong. But I think the only positive of this problem, maybe for the greedy solutions, is that you can kind of do a stress test. Like, I think you can kind of implement some complete brute force, which actually can help you come up with the correct solution. But as soon as you start doing it, you maybe can at least try to stress test it, like your greedy solution, and find a test that is wrong. But again, this is something that are usually done by the top teams, and also something that consumes the computer time. So you don't want to do it. You just want to debug with pen and paper, and then yeah, it may be hard to catch some greedy case. I think even when I was like discussing my solution initially of this problem, it also was wrong. Like the idea that I had, that I thought was working, it is not. In fact, like there is a case that is failing it. So yeah, it's kind of a tricky problem.
Yes, that one is really full of corner cases. Also, because you just said debugging with pen and paper. Interestingly, that's when I tell people about these competitions, that's the thing they are most confused by usually when I tell them, oh yeah, I just printed out and then like for those who don't know, you can send things to the printer and then someone takes the sheet and comes running to your desk and gives you the sheet. Um, and because there's only one computer in the competition per team, you don't want to use it to debug your problems. So printing it out and just searching for problems on the paper is actually the way to go.
Yeah, yeah, totally agree that it usually confuses people who are not familiar with such competitions because, like, what you're doing the programming with paper, like, how does it work? But yeah, that's the thing when you have pretty complex problems where the most difficult part, not always, but usually, is to come up with a solution and to check all of the possible cases and etc. So it might be the case that the solution, for example, for the B that teams are trying to submit, is pretty short. Like it could be just several lines of code. So there is no point in just sitting in front of the laptop and trying to do some stuff because you can effectively do it with just paper while your teammates would be implementing something else. I also think we can maybe discuss some other problem, I don't know, problem K or D. We can maybe also try our new technology with drawing and to explain the solution with drawing to our viewers. I'm not sure if this is set up yet, but if so, we can try. So I think we can take a look at problem. Let me just check what is mostly solved problem. D or K. So it seems like problem D solved more than the problem k, so we can maybe start with this one. So the overall statement of this problem is that the main character tries to build a dream catcher, basically. um, yeah, I think we can also show the problem statement. Yeah, that's amazing. So basically, the person is trying to build a dream catcher, and how he does it, he chooses some k, and then starting from the corner, like with index 1, with notch 1, you just connect the yarn k notches ahead, and basically in the end he gets the construction as you see in the pictures. And basically the goal is to make the total length of this red string that you used to do it. Yeah, the process stops when you reach the notch 1 again, and you want to maximize the length of the string.
I also remember this problem from the, this is only a shortened version of the problem statement that only has the relevant parts. The actual problem statement is a bit longer. And also for those who don't know, they usually come with a nice story. And I have to say, this story is my favorite in the entire problem set. So if you can somewhere find the problem set and are not currently working on it, this one I think is the best one. But we are not talking about how nice the problem statements are right now. We're talking about solutions for the problem.
Yeah, we can briefly explain how it works. So basically the first thing that you need to realize is that the answer is, if you pick some k, you have some n, then the answer, if I remember correctly, is like n divided by the greatest common divisor between them.
I don't remember the exact formula.
It should be like this, because you basically just need to calculate how much times it's fitted inside.
Yeah, I mean, I guess the place where I would start is intuitively, you don't want to choose like k equals 1, because two notches that are next to each other are pretty close to each other. But you also don't want a case like on the left to happen, where you don't use all of the notches.
Yeah, we can actually try to draw something if we... Yeah. Oh, wow. We have this nice whiteboard where we can draw how it works. So basically, if there are some segments, I will just draw some kind of a sun. It wouldn't be super precise. So yeah, basically, totally agree with you that you don't want to connect it like this, probably. Don't want to make the pass too short. So the first intuition is that you want to use as much segments as possible and just jump around.
Yes.
And this is exactly achieved when you have basically the greatest common divisor between n and k equals 1, I think.
Yes.
So then the difficulty here is that the total length is also depends on on an angle, right, between the two consecutive points that you connect. So basically, when you do it like this, this length of this chord would depend on this angle. So the only, as all the others, like let's say you have some k for which the greatest common divisor is 1. So the problem is that what if we have another k, I would say k1, where it's 2, so it's like twice less segments. But if it's theoretically possible that their total, the probably sinus of this angle divided by 2 is 2 times greater than your than the original angle. So you have this alpha for the K1, alpha 1 and alpha for K, and then basically you need to have the correct like limitations for them. But this is all going to be probably hard to understand and figure out. So you just basically look how it works, understand that probably you just need the largest angle you can achieve somewhere closer here, just because everything after the n divided by 2 is symmetrical. So then you just, I don't know, find the k that gives you the greatest common divisor being equal to 1 and being closest to the n divided by 2. And this is probably pretty straightforward to find. And I think you can also like draw some angles, draw some, I know, some sinuses, right? See that basically if you take sinus of alpha divided by 2 and on the alpha itself, then because of the limitations, to make it twice larger, to make the sinus twice larger, you can only take something that is pretty small angle, like less than 45 degrees or so, which means that you just, if you have some answer here, that it will be the optimal one. Yeah. And it's something, I think I've discussed it in too many details, but basically it's enough to just think, okay, everything is symmetrical, let's take n divided by 2, and then think about this fact, just understand it from some basic numbers theory, and then just find the right k.
I also noticed our drawing pad here, and the stream seems to be slightly offset.
Oh, yeah. Should we move it ourselves or no?
Okay, yeah, now it's in frame. No, it's. I don't think if you move it, it doesn't do anything.
Okay. Yeah, it's probably operated by our magicians behind the scenes. So yeah, that's it. I was probably saying too much details and maybe said something incorrectly here, but I think overall the idea is like this, and the proof is something like that. So
yeah, but as I said earlier, I guess that's not really a problem where people prove a lot. Like if I was in this competition, I would go. I would have this insight of the symmetry that you only need to check that going past n½ is the same as being before that. And then I would just iterate down, find the first one where GCD of n and k is equal to 1. And that's probably it.
Yeah, I can't agree. I still think that maybe somebody tried to prove it. Like, I think we can switch now our stage to get back to the main contest hall and see how is it going for the teams. But yeah, for this problem, totally agree. I just think, I do believe that somebody like spent some time proving it just because they may be a math guys, or it may be the case that you basically have some time while your teammates are implementing something easier. So during the first like hour, half an hour for contest, while everybody's implementing K, L, F, you have a bit of a time to just draw something on a piece of paper and like, okay, yeah, this sounds right. It's easy to implement and just check. Yeah, actually, we also have an update that the University of Cambridge already for some time have 8 problems. So they solved problem E some time ago. Yeah, the second place have 7 problems. So we have this nice view of the top teams. I think we have 2 teams today which qualify directly to the World Finals. And also some amount of teams, I don't know how many exactly, that qualifies to the EUC.
I think it's the top 13 institutions. And by the way, I don't think it's precisely the top 2 teams. Usually that's not important because most of the time it is. But here, both top teams are from the University of Cambridge, and only one team from each university can go. So right now it would be one team from Cambridge and then the University of Amsterdam.
Yeah, that's an important point, that only one team per university could qualify. I think we also can say that the first 12 teams are usually like considered as the best ones, and they got medals. So it's also very nice to be in the top 12. Right now, the limit to be in top 12 is like 5 problems. So if you solved 5, you are in top 12. But I do believe it would be closer to 7 or even 8, closer to the end of the contest. There are still a lot of teams trying to solve 4th and 5th problems. By the way, right now we see that the university that had first to solve on problem K, they are currently having just 3 problems, and they incorrectly tried both L and B. So I hope that they tried B, was stuck for a bit, and then we'll just forget about it and switch back to L, because yeah, if you get D, which we just described, it probably slightly more difficult than L anyways. Like, you need to think more than code.
Yeah, maybe it's just that they have someone who's really strong with constructive problems, and this person just did K very fast and is now trying to solve B in a constructive manner. And from what I know about this problem, you generally want to write a small brute force. Instead, you can solve it constructively, but that might be really difficult.
Yeah, totally agree that some teams could have this separation between the roles in the team, which could work sometimes pretty nicely. The same as behind the cameras and the team under the hood. I think you can see on the screens that we have different colors of t-shirts. Oh wow, we have our runners room seen there. We can see some jury members and our great team of runners who are basically running around to bring you the printed papers and also the balloons. That's probably second most busy guys right now after the contestants themselves. Yeah, so it was a lot of efforts to prepare everything, and now the team is busy working hard. I think they're doing well for now. It's 4 more hours to go.
Yeah. On that note, it's also pretty fun to get like a little bit of a look behind the scenes for me. I was contestant until last year, and if you're contestant, it looks like you don't really know what's going on behind past the contest hall. You come in, you go to the contest hall, you go out, and that's more or less it. And it's interesting to see how it looks just a bit past the contest hall.
Yeah, I totally agree. For me, it was the same. Like, you just go into the contest and you're like, yeah, whatever. Get up, solve problems, go to the closing ceremony, go to the opening ceremony in the beginning, and visit like the sponsor lectures, and that's it. So basically, all the things are organized for you, and you just need to relax as much as possible, except for the contest. But yeah, actually, there are a lot of things going on here and there. Yeah, we also have some insight that currently, actually, the top sponsor team who are solving the problems like in the parallel contest, they have the same amount of problems than our top students team, but they have worth penalty. So the students team are currently better than the best sponsor teams.
Yes, but if that top sponsor team is JetBrains, then that might be a bit scary for the top student team, because as we said earlier, being fast to solve and solving difficult problems are different skills. And I would actually assume that the sponsor teams are not that fast, but maybe can solve a bit more difficult problems.
Yeah, agreed. We'll see how it goes. Right now, our first team, Bra Open, is trying to solve the problem B, which is, I don't know if it's the best choice, but probably among the problems, what else left for them is G, H, and I. So yeah, probably that's the wise choice to look at B. Incorrect submission is not the best thing to have right now for them. It could more smooth, I would say. But yeah, that's a tricky problem with a lot of corner cases. I also like that we have now, I would say, more variety between the teams, because somebody who are right now in the middle around like 30, place 30, place 40, they're trying to solve problem A or problem J, which is nice. It's always nice that when it's not just everybody solving just the same subset of problems. So it's good to see that some teams finally realize that there are more solvable and straightforward, or maybe just solvable with a bit of a think problems than we initially saw with just F, L, and K.
Yes, but we're getting to a point for the top teams where it's actually difficult, maybe to decide, especially for Bra Open, what to do next. Because B might be a bit weird as a problem, but I think G, H, and I are actually a good bit more difficult than the other problems.
Yeah, I think but they have a lot of time. So right now it could be the like strategy to just decide altogether which of those problems are the most difficult one and just skip it for a time being, and then just split the three remaining ones between the teammates. As you also said before, they probably individually also pretty strong, each one of them. So yeah, they can just split it and try to think on them separately. And having so many time left, it's actually a very, very good chance for them to at least try to solve everything today. I'm still not sure if we would have any team that is able to do it, but they are probably the first one here to really try to push for it.
Yes. I would bet that G, H, and I, that at least one of them gets solved. I would even say that there's a good chance that all three of them get solved. But I'm not sure if they get all three solved by the same team.
Yeah. That's a good point, because they are so different in terms of the topics like that you need to know, you need to master to solve them. Uh, it's really great that we have this problem set that there's so variety of topics. So yeah, it's definitely could be the case that somebody is not so good at some math or combinatorics or with dynamic programming, and then you just can't do anything. It's actually interesting that the top three teams are all from the same subregion. We have top three teams from the UK preliminaries. So it's two teams from Cambridge, one team from Oxford. And only after them, there are like a couple of teams from the BAPC, University of Amsterdam and Utrecht. Then we have German team from the Karlsruhe Institute of Technology, your favorites.
Yeah. I mean, right now it's looking really good for Cambridge, as we said, but I just see the infinite loopers just solved problem A. So once they solve problem C, and I think problem C is also quite doable for them, then they should also be in a really good spot. Because my opinion of the team is also, like, I have a bit more knowledge of them because they're from our university. And I would also say that they have especially one person who is very, very strong individually and is probably going to solve at least one of the three difficult problems.
Yeah, let's wait for them to catch the others. It's great that actually already like 5 teams solved C. To be honest, like initially I thought in the wrong direction on this problem, so I thought that it would be a bit more hard. Like initially I thought that it's closer even to like G or H, because like kind of just the solution, the idea for H just came up faster to me for some reason. But yeah, actually, if you are good with graph theory, it may be much easier to solve C. So it's good that there are many teams who did it before even solving K, for example. Another team from the University of Utrecht managed to solve C before K, which is quite funny because K is pretty straightforward. Yeah, I also wanted to say that the team that we're also rooting for, because they visited us yesterday, the Submit from the Saarland University, they currently have 4 problems and they try to solve K. I do believe they should manage to do it, and then it will give them 5 problems and the place around from 20 to 30-ish. So yeah, they still have a chance to qualify further, I would say. So yeah, let's see how it goes for them. They have a bunch of experience in their team.
Mm-hmm. Yeah, we were talking about it yesterday a bit. Like, I expected to do them. I expected them to do very well, because I know that they have at least 2 world finalists on their team. But they were a bit more pessimistic. I don't know. I still have hopes that they manage to at least get to the European Championship.
Yeah, that's basically the maybe the main hope for a lot of teams today, because yeah, you see that those 2 teams already have so small penalty and so many problems, and you're like, okay, so now we are fighting for the top 10, which is also quite challenging.
Yeah, but for the European Championship final, for European Championship, there's also the nice thing that every university can only send 1 team. So for some teams it's nice, for other teams it's not. Like Unity and open parentheses. These 2 teams couldn't go after the current scoreboard, but that means that teams lower on the scoreboard can go instead, and it's quite nice if you don't have to like push for that much in the placement and can still visit Warsaw.
Yeah, it looks like the competition inside the University of Cambridge is like really fierce. It's like we have 1, 2, 3, 4 teams in top 12 right now, and anyone can jump higher except for probably the Bra Open team, because they solved everything that we believe should be solvable for the strong teams. But yeah, all the rest are still trying to catch them. So now it's really the challenge if you manage to beat the hardest problems.
Not being able to jump higher because you're already at the very top is probably a good problem for Bra Open to have.
Yeah. I think we can actually right now wait for a little bit for the other teams to catch up with leaders, and we will take a very short break and our live stream, and we'll come back in a couple of minutes. So stay tuned.
Is it okay if we do wait 1 second?
Yeah.
Okay, because the Infinite Loopers just got the C accepted and should be now in 2nd place.
Yeah.
All right.
On this high note, we'll make a short pause and we'll get back soon.
Yeah. Thank you.
And welcome back, everyone. And we are now accompanied by the member of the jury, who will explain us some tricks and problems and how is it going. So, Jurgen,
Yeah.
how is it going so far? What do you think about the contest, about the contestants? Are they doing well?
Yeah,
Or
the
you
contestants are doing really well. Like we see now, 3 solves on B. That's a lot. We were expecting many wrong answers on this problem.
But we had many wrong
Yeah,
answers.
but now they fixed their bugs, so that's good. But it's also scary that they're this good, because they only have 3 problems left. One team, yeah.
It's also crazy that two teams out of 3 did it with the first try, and the difference in the time penalty is like 2 minutes between first and the third one.
Yeah,
So
yeah.
like the first University of Cambridge team did it in 89 minutes, then the next one in 90 minutes, also from Cambridge, and the third team also from Cambridge. So it's just crazy. They nailed it. I don't know what they studied there. Greedy algorithms, corner cases.
Yeah.
It's actually now becoming more and more challenging because right now we are getting closer to the point where you need to either do B, which could be kind of tricky, or do one of the hardest problems to probably qualify to the UC.
Yeah.
On that note, I heard some disagreements on the difficulty of problem B,
Yeah.
and we have also seen like a lot of wrong answers so far on that problem. Do you think teams should do B now, or do you think G, H, or I is actually easier?
I think I would definitely put like one teammate on one of the hard problems, just so they can start thinking about it, and then. But I think B is the next problem to go for, and maybe you should just make sure that you test it well on your own machine before submitting, because you see all these wrong answers and you don't want to get wrong answer yourself. And also, there are many approaches to B, and some are like really prone to errors, and some are more straightforward but more code. So you can try to choose what to implement. Yeah. And I think we looked at the codes. I think the top team, they took the more straightforward approach, but had a small bug somewhere and eventually fixed it. And I think some other teams, they have done some casework and then a greedy, and it also works.
Yeah, and I think we also heard that the sponsors teams also nailed this problem, also with some kind of greedy approach. So yeah, it's definitely the next step to do in the contest. So probably we'll see more teams doing it. At the same time, teams who like 2 out of 3 teams solved it haven't yet solved A and E. So yeah, I would assume we will pretty quickly see several teams with 9 problems.
Yeah.
And we actually have like thoughts from our analysts, from Pavel, who is working with us behind the scenes, who is assuming that you would actually need even 10 problems to just qualify to the UC. So that's the bold prediction we have.
Yeah.
So we'll see how it goes. It might be the chance. I think it would really depend on a time and speed that would be required to solve one of the 3 hardest problems.
But now that there's already discussion about a lot of teams getting 10 problems, and there are only 12 problems in this problem set,
Yeah.
are there already like some considerations that you might freeze the scoreboard early if teams get to
11.
get to 10 or maybe even 11?
I think sometimes in our sub-regional, the BIPC, they have done it. In NWERC, I think it's usually not done. And I would bet, I hope this is also the case, that these 3 problems, like solving 2 of them will take a long, long time. So I hope this keeps the contestants busy.
Yeah, I agree. I think that if anyone could solve everything, it wouldn't be done more than an hour before the end of the contest.
Yeah, yeah.
I don't think so. I hope so. It would make it much more interesting and fun.
But what's also scary is that they have now 3 problems and also 3 contestants to look at the problem, so they can just split it and start thinking about each problem separately.
Yeah, we were discussing that you could do it even when you have four problems remaining, right?
Yeah.
Because then you just see that one of them is probably too difficult. Like, let's say problem I, you're like, okay, those images with the samples are probably too hard to handle. So yeah, let's just skip it for now.
Yeah.
And switch to the other ones. Yeah, it's also worth mentioning that we almost all the teams solved at least something, which is good. We
Yeah.
have like 132 teams that solved at least one problem, and a bunch of teams who tried but not yet managed to do it, around like 6, 7 teams. But I do believe they still have a chance. They are trying to solve problem L, problem F that should be solvable. So yeah, I hope that everybody would get at least one balloon, so they would not leave the contest hall without balloons at all.
Yeah. Then maybe also because E is now solved so much, we can maybe talk about it.
Yeah, that's what I also wanted to ask you. Since we have the member of the jury who should know how all of the problems work, we were speculating a bit about the easiest ones before that.
Yeah.
But since you are here, maybe we can use you to explain the problem E. So maybe we can at first check the statement and look at the slides. Oh, here they are.
Yeah,
So
yeah. So I can quickly explain the statement. So we have a lot of lights that are at Christmas markets, and we can push a button, and then we can change one of the lights. And the lights come in 3 colors. And when you push the button, it randomly takes one of the 3 colors, the light that you press. And at the end of this process of pushing buttons, we want to make all the lights the same color. And the question asks, what's the lowest expected value if you push the buttons optimally? And there are like some samples. So for example, if you have 2 lights of RB, then you should just start pressing one, and hopefully it changes to the same color as the other light. And this, if you look at it, it's 1/3 probability. So then it takes 3 steps on average to get to RR or BB or something. So, and now, yeah, then the constraints are pretty small, like n less than or equal to 100. So there's a lot of stuff you could try. So this maybe, because it's open and it's maybe a bit harder even.
yeah, so let's dive into it and
Yeah.
see how the solution works. We could open our drawing magic screen, so you will be able to show everything. Yeah, and here it is.
So let's see.
Yep.
So at first, okay, I will draw some. Oh, what is the? Let's see.
Let me just quickly help you. Yeah, this one.
So I just make some small example. And I draw it in a specific way. So here we see like some small example. And what we also see is that at first we want to make everything the same, but so the order of the colors doesn't matter, actually. So only the amount of each color matters. So we can have like, we can encode our state as just the number of R's, that's 3, the number of G's, that's 2, and the number of B's, that's also 2. And now the question is like, which color should we press? We only actually have 3 options. We should press blue, green, or red. And it turns out that the optimal way of pushing is always to choose the one which has the least frequency. Or if there's a tie, you choose any of them. So this means we should now press a B, for example. So just press this B. And then we should think about what are all the options that could happen. And now, so the easiest option is a B. So then we stay in the same state. So nothing happens. Probability 1/3. Then it can change into an R or into a G, and this updates our state to something else. And what we can see is that because we choose the smallest color, the smallest frequency color, and it changes to one other thing, it means that the smallest color, if it doesn't stay the same, it will always go down. And this means that there's an order of the states in which we can process them. And this means that we can use the standard trick of dynamic programming. So let's just DP, that's the short. So our state will be like the 3 variables, like number of R's, number of G's, number of B's. Then we take the smallest frequency of them and look at these 3 cases where the thing goes. And then we have like one circular transition where the B goes to itself. And what we can do then is, for the circular transition, we know that's probability 1/3. So actually what it means is that we'll take, I think, I have to think about it. Don't quote me on this, but I think it's 3/2.
Yeah, that's correct.
You take expected value 3/2 steps before you go to one of R or G. And then you transition to this state and you calculate the expected value. And then in the end, you just count the colors in the initial string and you can just read off this value. And you can see this is like n to the power 3 states. But like, okay, the sum of them is equal to n. So you actually only need n² states. So it's an n squared solution, but you can even make it faster, but this is not needed because n is only 100. So yeah, this is the solution. And then I think the most tricky bit of when you think about this problem is what light should I flip? And you need to come to this conclusion that you should do the lowest one. If you don't see this, it turns out it's still solvable, but it's much harder. So yeah, this is basically the whole solution.
I kind of agree, but at the same time, it seems like the idea to flip the smallest one is kind of intuitive.
Yeah, it's intuitive, but if you are someone who thinks, yeah, I want to prove it first before submitting, then it could be like a hurdle. But if you think, yeah, it will be probably correct, and you try it on the samples and it is correct, then it's not so hard. But yeah, so it's maybe a bit of a mindset you also have to have.
That's probably for why for this problem we have kind of a separation. There was a bunch of teams who did it pretty quickly. I wasn't even expecting somebody to solve it before like L or K.
Yeah.
But then we have like just a bunch of teams for which this problem is like fifth or sixth.
Yeah.
So yeah. We even have still a team in the 8th place, one of the Cambridge teams who like just hasn't yet solved it. So yeah.
Although I would guess at some point you just look at the scoreboard and you see how often it is solved, and then you think, okay, it's probably the thing we think about. It's probably correct to just choose the light that appears fused.
And it turns out, we don't have the solution slides, I think, here, but one of the authors, he found a way to write almost a like formula just to get the answer. And the formula only consists of n terms that you sum together, and then you get the answer. So it's even doable to do it in ON, but this is not needed.
Yeah, and about the proof, it's the case where you just look at the scoreboard and you're like, thank you guys for proving this for me. And now I'm just implement the solution I was thinking about, And we still have only one team with 9 problems, and everybody's catching up. But now it's 7 to be in medals, and probably 7 to qualify to EUC already. Yeah, so it's pretty...
Like on the one hand, it's a bit sad that's going so quick. But on the other hand, like if the contest is decided on hard problems, this is also something that is actually pretty nice. Like people's actual skills and problem solving are tested, instead of that you have so many easy problems but they're hard to implement that you just get stuck on them. But
yeah, it was a bit of a sprint in the beginning. Now teams are settling in for the long marathon and just trying to get, like, even solving one more problem right now for the top team, or just getting to 10 already seems like a very good step to take.
Yeah.
And at the same time, I think that it's also exciting for the teams in the middle. If you have like 4 or 5 problems right now, or 3 problems, you still have more than 3 hours to go. And like you have a lot of things to work on. And it's probably more exciting than if you have like 4 kind of easy problems, and then when the others are too complex for your team level, you just, I don't know, spend 2 or 3 hours trying to do something, and then you just give up and do nothing for the rest 2 hours. But if we have a variety of problems on different topics that could be solved by many teams, it's also good to practice, to prepare for the next year if you are not top team yet. So yeah.
I'm really curious when the first submission of one of the hard problems comes in. I will also check it out just to see what the teams are doing.
Yeah, there are no submissions yet for them. Maybe if we see on the contest floor any of the top teams at any point, we can try to see if they're really clicking buttons and doing something
or
already.
Like just thinking.
Or just thinking. Probably soon we'll see somebody. But I don't know. I think maybe during next hour we will definitely see submissions. But it may take a while for the teams to do it, or there is a bunch of balloons.
We even just got the camera directed directly at Bra Open, and we can very clearly see that
they're not typing.
They are not typing. There's a lot of thinking being done over the paper.
So at least other teams have some time to catch up with them. Yeah.
I kind of wonder what problem they are currently working on.
I would assume that they split it, and maybe two of them working on single problem and the third person is working on another one, but it would be much wiser, I assume, than just dedicate all the time on a single problem when you have more than 3 hours to go.
Yeah. So I think in such case, when you don't have anything to implement, our strategy is usually in our team, like we solve all the problems independently, but we should have some timestamp where we have a meeting and share the ideas so that you don't get stuck. And maybe switch problems if you think that this problem is actually not for me.
Yeah, I would I would also ask if I am working, let's say on I would ask my teammate to read it on himself without explaining him the statement. So
Yeah.
then we make sure that we understand it in the same way and noticed all the limitations and restrictions. Then we just exchange the ideas that both of us, he has from the top of his head and I have because I thought about it, and then we either exchange or he just said, okay, go on, continue working on it.
Yeah.
So yeah.
I've also noticed from my team, it's kind of a delicate balance how much you talk to each other, because if you talk too much, you might get stuck together in the wrong direction, and it also takes time. But if you don't talk to each other, then you might just cover the same ground twice. You might have the same insights twice, and that's just wasted time.
Yeah.
Yeah, for sure. And I think on the we see them again now. They are communicating, so maybe somebody realized something. But yeah, I think on the later stages of the contest, it may be optimal to do the same problem because, for example, you may have some teammate who just don't have any ideas at all, and you can tell him like, okay, maybe you could prepare some test cases for me, let's say, or something like that.
I see one team name. It's like T-Kit or something.
Yeah.
It's pretty like, did they know this problem K existed or not? Like it's pretty close to problem K of this contest. That's really funny.
I mean, I mean, it's the university name. So
Yeah.
I would hope that there is the teams from our university
Don't know it.
in generally
It's a good coincidence.
in general have KAT in their name.
But also funny, like we saw at the judges' room, we were looking at K submissions. We saw one submission which had one wrong answer. And we were thinking about what is it? Like the problem is something with you have to play some KIT once. But they had the string KIT IK. And that means like they have the KIT forwards and the KIT backwards, so it counted twice, and it was wrong.
That's exactly what you get when is just one person who read the problem statement and didn't read that you can read the word backwards and forwards.
But like it was a pretty specific case why it went wrong. So yeah, hopefully they fix it soon. Yeah.
Also, I have a guess what Bar Open is working on right now, because I think that I saw this specific page in the problem statement open, which is the sample site for problem I.
Yeah.
Yeah, I think we also saw that one of the team members explained a lot of ideas to others. I thought that he's explaining some solution, but it seems like not yet. Maybe he just shared what ideas.
Yeah.
Yes, yeah.
Other Cambridge team.
Yeah, they're still working. Yeah, so while we are waiting for the teams to do something interesting and open one of the hardest problems, I think we can take a short break here at the live stream. So thank you for coming.
Yeah, it was nice.
Yeah, we'll see you at the EUC probably. Yeah, for sure. Good luck there if you're participating.
Yeah, so this is a bit weird story, but last week I was at SWERC. And I was also jury here. So now I'm contestant and judge at the same time.
That's nice. Just tried it both from the both sides.
Yeah, it's
so,
a really nice perspective, but yeah, it's a bit weird how it went. But it's nice that I could still participate.
Yeah. Thanks for coming.
Yeah.
And yeah, everybody stay tuned. We will come back in a minute. And welcome back, everyone. Here we are again, and now we have a representative of sponsors of the company Freiheit with us. So, welcome, guys. Good to see you. So, how is it going so far? What do you think about our contest?
Good, good. I like it. I like this format also, and seems so far now it's really about the three hardest problems, which is also interesting dynamic happening now.
Yeah,
I think.
absolutely. For me, it's actually the first time being at a contest at all. Completely newbie to this whole thing. I mean, I know kind of about the scene before because lots of our colleagues have that background, but I'm here now for the first time and seeing it now basically live and the teams going at it is kind of crazy because actually as somebody not trained at it, it's black magic.
By the way, we already have like 3 teams with 9 problems, and suddenly only 2 of them are from Cambridge. We also have the Hasselplatter Institute. Right now seems to be Oak on the 2nd place, which is nice to have some variety of the regions in the top teams. So yeah, now, as you said, more and more teams are reaching those 3 hardest problems. But yeah, since we have you here, have you read the problems yourself?
Yeah, I skimmed over them. I have no idea how to solve them. They seem fun. I already told you before, I like the Christmas theme. That's from the outsider's perspective what I can take away from it. But yeah, I think the team is happy actually that there's a multi-pass problem. I heard that's new. And they actually mentioned yesterday that this is something they're looking forward to solve.
Yeah, unfortunately, it's one of the hardest ones. So maybe it's like the problem H, which has like 0 submissions, I think, up until now. So probably not so many teams would really try to submit it. But anyways, at least for the top teams, it's a chance to work on it. Yeah. But what about you guys? Maybe you should tell us more. Why do we have you basically here today? Why you decided to sponsor this event, and what do you do in your company? Just share with us.
You wanna go? I can do, okay. Yeah, so basically, lots of, I mentioned before, lots of our colleagues have a background in competitive programming. And we really like working together with them. So they're great problem solvers. That's what our company does. It solves software problems. And they're really, really great at it. So this is really something that we noticed. If somebody has a background from the scene, they're very good at what they're doing, and this is also why we're now funding it, because basically this is then where we get an influx of new trainees, of new talent, I mean, that we do not need to train a lot, and this is fantastic. So that's basically, in the end, a bit selfish what we're doing here.
I think it's both at the same time, because even like each such competition means that there are even more teams in preliminaries and teams are training and etc. And even if some teams are not here today, if they didn't qualify, they at least now maybe know that such competitions exist. They maybe look at the problems, and like I would say overall average level of problem solving is increasing with the more popular those competitions are. So even if you are not the very, very top contestant, you have some experience with it, and that makes your life easier, cracking the real life problems at work as well. Yeah.
And I think another thing that we noticed is also that this is like kind of a community, so that people that compete here know each other very well. They know how it is to work together actually in teams, and also I mean teams switch up and so. So this is really something that we noticed, that there is a community, and this is also how they then do software in the real life, that they're not like lone wolves, but they're team focused. So this is also really cool to see this again here with the teams competing.
Yeah, this I also like about the format, right? It's not like everyone fending for themselves and like working on things separately, but you have to work together. You like cannot solve everything by yourself. You have to like, even if you could, you have to coordinate. Okay, who does what? Who is working on which part? Because you cannot be at the same laptop all the time.
Yeah. And again, from an outsider's perspective, this is not something I would have expected. So coming from lead code and like advent of code, just sitting on my own laptop, super cool.
Yeah, I think it's like for an outsider, it's kind of unexpected, like really programming competition, but not everybody is just coding. So what's the point? But yeah, it really teaches you teamwork and deadlines to do some syncs like every hour at least sometimes. You groom the problems. I don't know. Yeah.
I've also learned over the time to not open with, it's called competitive programming, because when I say programming, people have all kind of ideas what it could be, and put the more algorithmic problem solving first.
By the way, we also have another team from another preliminaries from University of Utrecht with 9 problems right now. So it's 4 teams already. I think more are coming. Now it's you need to have 8 problems, at least 8 problems to be in top 12 in medals. So yeah, at least 8 probably also. Oh, now even 8 is not enough to be in the medals. Like we have 13 teams. So yeah, it's pretty tough, pretty packed here in the top. But yeah, can you tell us guys maybe more? What do you do? What your company does? And like, yeah.
Sure. Yeah, we're problem solvers. Actually, that's how we see ourselves. It's literally so. We do software, obviously, but the common denominator is that somebody has a problem that needs to be solved, and then they approach us. And over the last 25 years, at least, that's how the company was run. Somebody hears of us or has already worked together with us. They say, "Hey, we literally don't know any further. We heard you people are great. Can you please help us?" And then that's what we do. And we've done so many projects across different industries and with different dimensions of what software we do. That's literally the common denominator there. So we're working in currently in the retail industry. We do wares and goods systems. Currently porting the Lidl wares and goods system to the cloud. Very exciting. That's the plug here. But yeah, we are also building, for example, currently a very fancy Dropbox for dentists, where dentists can visualize their 3D scans in the cloud. So we do all the rendering of the 3D scans in our backend. Also, we brought Spotify to the Mercedes. We worked in the aviation industry. There's like lots of different things. Every time it's hard and somebody goes like, well, it's pretty tough and we don't know further. So,
And what's common across all these projects in like very different contexts, very different industries, very different tech stacks sometimes also, is that we always work together with the client to find out, okay, what exactly is your goal and what is kind of the timeline. We are big fans of deadlines and also like actually doing things inside of those deadlines and making sure that we can deliver everything on time and on budget.
which is inherent. Sorry.
No, go on. Sorry.
Which is inherently part of the problem again. Like this is really fast, and also coming back to the deadline, it's part of the problem, and this is like where we're really good at.
Yeah, I guess I just wanted to say, for me personally, it sounds quite nice. I think one of the greatest things also in competitive programming was always just to learn something new and approach new problems and just have something different every time. So yeah, I think a company that just does everything and where just problem solving is at the front sounds quite nice actually.
Yeah, so we are 85% engineers, and this is really our goal, and also what keeps us happy, because I think engineers get bored quite quickly, at least the good ones. So this is also where this is coming from. So it's actually self-beneficial. Every time we take up something challenging, it's new and exciting, and you don't get bored. So that's also why we like what we're doing, because we're not repeating ourselves. We take on new challenges every time. Yeah.
Yeah, that sounds interesting indeed, and quite similar to how the contest works, but just probably longer than for 5 hours.
Yes. Yeah.
By the way, the first team of the Karlsruhe Institute of Technology, Institute Loopers, they're trying to solve problem G right now. They already have a couple of submissions. I think both of them are unfortunately incorrect. Maybe we'll learn later on what they're trying to do, but generally I think this is probably the easiest among those 3 problems. I'm not sure, but for me it feels like that, but maybe it's just my preferences.
I would kind of agree, but I guess the other problem is they don't have B so far. As I said earlier, I know a little bit about their team organization. And what I think is happening is that 2 of them are the 2 of them are currently working on problem B, and one member who's individually very strong, he's probably saying, okay, I'm going to look at something else now, so we don't all are on the same problem and we are a bit more time efficient. And he's probably trying to get the solution to G right now.
Yeah, could be, but this could be a problem only if they don't get G. Because like, if they manage to solve G quickly, that gives them an edge basically, because B is probably easier, and yeah, so the fact that they don't have B yet is only a problem as long as their G solution is not correct. But guys, what do you think? What is the, I don't know, most valuable skills that you saw in the past contestants who you're working with, which they developed here? Because obviously, to be successful in programming competitions, you need to master a lot of skills. It's both the teamwork, your speed, your attention to details, like, I don't know, able to invent something new, and also the huge theory behind it, like math and algorithms, and etc. So what do you think is the most valuable, maybe, or translates better to the real life problems?
Yeah, I think it's overall it's like the combination. You named a bunch of things, right? And all of them are important. But like, yeah, overall it's this kind of looking at something and like getting really into the details and like probing like from the beginning, like seeing the problem, understanding the problem, and then having good strategies of like approaching it, right? So I think that's yeah, very very valuable in what we see, and also why we have a lot of people with that background and like to work with them.
And I think there's like this meta thing to problem solving, right? Because all of you named is basically also in terms of competition something that in other sports is also something that's needed. But in this meta reflection on how does problem solving work? How do I even approach a problem? Like, I go in, what do I need to do? Something like in the beginning it looks impossible. Okay, calm down. What are the steps I need to take? And this is something that is very specific to this, that it's actually something that can be trained. It's actually, I have the feeling, at least when talking to my colleagues, is something that I also learned in physics, but just this is way more, this is like a real training, right? In physics, you do academia, you like in academia itself, you do your exams, you're also training for something, but here it's a sport. You want to be really good at it. So you train this meta thing of how do I approach problems? How do I chunk them down? What kind of strategies in problem solving that go beyond just crystalline knowledge of programming or algorithms are there so that I figure something out? Because maybe you just get stuck, right? Maybe you don't know the solution. Maybe you don't have the right algorithm currently out in your head. What kind of strategies can I now take to actually make the problem solvable? And I think this is something that the contestants learn.
And I think also every problem, and then like on a bigger scale, every kind of problem set is kind of like a mini project that they're working on, right? It's like they have to do like a good project plan at the beginning, like who works on which problem in which order, right? And then, I don't know, you have to like come up with the solutions, you have to validate them, maybe you check them with your teammates, you implement them, you test them, and in the end there's the delivery of saying, okay, this is what I believe is the correct solution.
Yeah. And I think that's important, right? They actually deliver something in the end.
Yeah.
It's not a pet project which then lies around a GitHub repository, but you actually, in the end, need something that's somehow running.
Yeah. Almost every one of them. We already have 135 teams that have at least one correct submission, and suddenly the problem F is more popular than L in comparison to the beginning of the contest. I think we initially had most of the problem solved was problem L, because probably just the last one. Yeah, but we still have several teams that haven't solved anything. So let's hope they manage to do it by the end of the contest. They have more than half of a contest. So yeah, one of them actually tried to submit 4 different problems. So who knows, maybe suddenly they will just appear in the top.
I also see we are now at 136 because NHH coders just did the F.
Oh, yep, yeah, that's right. By the way, we have some insights that the overall idea for the problem G, one of the 3 hardest one of the infinite loopers teams, is correct, but the implementation details or some small details in the solution are wrong. So probably they're currently trying to handle this, to as in real life, to find what is going wrong, why the server is down or whatever, and fix it. So yeah, get the submission, which is quite good for them, because yeah, B should be definitely easier. I do believe you know them, so I think they should manage to do it. So yeah, maybe we will see the non-UK team on the first row for the first time during this contest, or at least in the last hour and a half.
Plus, Team DFS is also now in 4th place. They just also solved problem B. So Cambridge not completely dominating the top anymore, although still very, very good.
Yeah, I think...
I wanted to ask him something, so if you have another note on the scoreboard, please go ahead.
Yeah, just quick note that now it's almost perfect situation, because the first 4 teams are each from one of the 4 of different preliminaries. So basically we have one leader in each of these preliminaries that have right now 9 problems. Unfortunately, it's already changed and we have 2 Cambridge ones, but at least for a short moment of time it was perfect. Let's hope that they manage to do it, to make it perfect after that. But yeah, anyways, it's good, because I think the Nordic teams were a bit lower than others. They had they were a bit slower to get 8 in the beginning of the contest. The same for the BAPC teams. Only 2 of them are right now in the medals. So it's good to have like a variety of teams in the top, because usually, just based on what I saw in the past, usually it may be the case that teams from the same universities, they are good at same topics, just because they attended same lectures and etc., have similar trainings. So when you have hardest problems, they could be opened by different universities, and then it makes it more fun. So it's good to have different universities in the top. So yeah, sorry, go on with your question.
Right. So I remember before I was a participant, or even when I was, but not in the first team, our first team from KIT had, I guess, a special member, because he was really bad at programming. He probably could barely solve like 2 or 3 problems here, which is still, for a top team, you expect generally more from each individual member. But he was really good at math, and he was just solving the problems, and then handing them off to his teammates and saying, okay, do this, 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 and they would handle it. And I was thinking about it, because you are a software company, but you said you're a physicist.
Yes.
So I'm kind of making the assumption that there's something similar going on here, that you don't work as much on software and maybe maybe help out a bit more, but maybe I'm wrong.
No, so actually I'm doing software all the time. But so the thing is, I learned in university how to program, right? The thing is, I didn't learn really software. Like, I had some CS lectures and I learned something about algorithms. All of it probably forgot immediately. I know that stuff exists and I know what a quicksort is. I wouldn't know how to implement it from the top of my head, and I wouldn't know the space-time complexity. That's basically physicist thing. We need to get stuff working, and then, well, the details can be looked up later. But so I learned kind of programming and like for loops and if conditions, right? Stuff like that. But this is exactly what we as a company then do, is saying, well, we think, for example, most MINT graduates, especially math, physics, obviously computer science, we're not talking about them now, they know how to solve problems, and this is more important than crystalline knowledge of certain things, because these can looked up, or you can ask people, and this is what I literally do. Like, if I'm going like in my everyday execution of my little programming things I'm doing, I notice stuff is slow, or it's not behaving as I want to, and I feel like I'm stuck, I actually approach the people and they look at it and go like, well, you're not having chosen the right algorithm. And I go like, well, which one should I have chosen? And then with this, it's kind of a playful thing of learning that. And I think actually what's underlying in the education, ideas of physics and math and computer science, is that you also learn a playful approach of, again, problem solving. And I think this is really important. And at least in our jobs, we solve complex problems. And this skill is then very soft, but more important than having very specific crystalline knowledge. Doesn't mean you should, I mean, obviously I'm doing a job and I'm joking when I say I don't know how to program, but I'm just not as firm on certain things as people with a computer science background or from the competitive programming scene. But this is something that we noticed that works very well. Also, we as a company take quite a lot of care to actually train people when they come in, because obviously when somebody did math before, there might be a lot of things to teach, but this is also that we trust them. So if somebody has a background in these subjects, we think they also can learn a lot and they have fun in learning. And then we teach them on the job while doing something and bring them up to speed as fast as we can. So I hope I'm doing a good job as a software engineer by now.
So you have like kind of internships for like graduates, or you just educate them when they join, or how does it usually work? How do you usually hunt students and etc.?
Yes, so we educate them when they join. For internships, we usually aim for really placing them in projects and working together with them. So this is for us usually then, because we need to onboard them and until they can actually work and have fun at work, it takes some time. So usually those are for us only if somebody is doing interested in doing an internship for 6 months. Very welcome, by the way, and we don't have it written out on our website, but you can drop us an email. Maybe we can figure something out. But when somebody joins the company, we really have trainings and self-study lessons. We have loads of books. Feels like the whole O'Reilly library in our office by now. But most importantly, we do a very, very thorough onboarding. So our mentorship that we do with our newbies when they join is very, very, very close on a daily level. And it's really the 6 months pushing somebody to where we think they should be, where we think we can work together with them.
Well, while we're on the topic of like opportunities for students and how do we like what do we have to offer? Sometimes we have like programs or workshops that we do specifically for students at our office. We also have a program that is not set up yet, but we're planning early next year to have more of like a series of remote workshops that is specifically for students, where they can also kind of hands-on try out a few things, maybe like some like real problems from back-end or front-end, or like more infrastructure focused things. So I don't think we have this on our website right now, but yeah, maybe next year it's coming up, and if you're interested, then you could also join those.
Yeah. Sounds nice. Yeah.
I also wanted to comment on your reply. I think it sounds really nice to really have a company that values problem-solving skills. I would hope that maybe also some other sponsors do that, but it's nice to hear that you do at least, because it can be a bit frustrating to just have HR people who basically want a list of you have this many years experience in this programming language, and then blah blah blah.
Yeah.
This is also very important for us. We always like never look for people with a specific stack, right? Because we're looking for people who like can program and want to learn and are or will become like great software engineers, right? And then the like a new stack or like a new language, new framework you can learn, right? But the important parts are the like things that are the same between different technologies, and how you set up code and projects that work and that are great to maintain afterwards also.
And this is also actually why our recruiting is done by engineers. So we literally do the first interviews with the applicants, because we think, well, we are engineers, we have to work with the people together. And I think maybe it's like interview smell the same as code smell, you know, like something is off. I'm not sure whether this is a fit, because everything on paper checks out, but I just don't have the feeling the engineering part here is there. And this is something that we as an engineer can judge, and an HR person couldn't. So also this is great care, where we really take each applicant with great care and really dig into it and do not have this where we need 15 years of .NET. Yeah.
By the way, we are right now also seeing the sponsored teams from the JetBrains, and we know the inside that they have successfully solved problem G in the parallel contest.
Wow.
So, but they still have 9, so they probably don't have B. But I see that Nias is currently writing something, so probably they will have 10 at some moment of time, and other team members are discussing other problems. So yeah, maybe they have more ideas, which is huge. Yeah, and we also know the Jumpstart and probably Albert Plant team has. Oh yeah, Infinite Loopers managed to do it. Nice. That makes it even more fun.
That's very exciting.
Yeah, because the sponsor teams, they had 9 with G, but the time penalty was worse than the top 1 University of Cambridge team. So they wouldn't be on the first row if we merge the scoreboard, but still, that's huge. And yeah, Jumpstart and Albert Blunt teams has 8 because of B. So yeah, that's the top result. Do you also have a team participating?
Yes.
Yes.
How they are doing?
Actually, they're a bit rusty, it seems. Last time we checked the scoreboard, they didn't have that many problems. Might be also strategy that they just then roll up the field from behind. But I think they're a bit struggling. At least they were. Let's see how the next hours continue. But I mean, like in terms of JetBrains, this is really impressive. Like, shout out to that. But we're really rooting for them. I think they haven't competed for the last 2 years, 3 years. I'm not sure.
Yeah.
But I think they already said before that they want to start again. So maybe this is just the start now of a second career.
Yeah, they have a team that basically consists of people who won the world championship multiple times. So yeah, probably in the future you will, like when you hire some more students who will qualify to the world finals, like this year, next year, you will also have a team that consists of basically like
that would be exciting.
couple of times world champion, and then you can
yes.
also try to be the first.
Because they're like a bit like Rocky coming back, I feel. But having some fresh blood would be kind of exciting. Please apply.
We also get an insight that KIT team, to solve the problem G, it looks like they just deleted like 2 symbols from the implementation, just uncommented some line of code that was filling in some default starting array, and they got it correct. So yeah, good for them. Good for them. It sometimes it's hard to find some little mistakes when you just had some typo or just forgot to clear some used array in the middle of the implementation and now struggle to find something. So yeah, good for them to find it.
I don't know, is it possible that we can also see this line of code on stream?
Yeah, I think we can. And yeah, I get an update that they not uncommented it, but rather commented the line that was doing something random in the solution. So yeah.
Yeah, it's a bit weird. I think the diff is not from the wrong to the right submission, but from the right to the wrong submission, and that's why it looks a bit weird.
Yeah, we will probably now show this picture on the stream pretty soon, so viewers will get the idea what are we talking about. By the way, we are almost in the middle of the contest. It's like almost 2.5 hours past. We have 10 teams with 9 problems, so it seems like you definitely should have at least 9 to qualify further. I think in the remaining part we will have more than 12 teams like that. Yeah.
Okay. And
yeah, here it is.
We have the code on stream, and it looks like all the line is doing is filling out the inverse array of A, and we have. So as I said, it's a bit confusing. They commented out the line, so it's not actually the compiler doesn't look at it anymore. It basically doesn't exist in the code anymore. And if we look at the line above, there they said A inverse equal to A, which is a bit weird to initialize it like that. But what that basically means, if commenting out those works, is everywhere they used A inverse before, they should have just used A, and adding these two symbols now. Oh no, we got another update. We
are making it fun.
We were once again wrong. They uncommented it, so they actually need this inverse array, and now they have it set up correctly.
And we have the second team who also solved the problem G, by the way. It's the Trinity team from the University of Cambridge, and it was the team that was fourth among the Cambridge teams for the most part of the contest. So this is the example how you fight back from behind, even if there are more teams. And that's exactly what we were discussing with Jonathan in the beginning of the contest, that the fact that you implemented easiest problems quickly doesn't mean necessarily that you will be the best, because maybe some a bit slower teams would just catch up with you and they just solve the hardest ones that you have no idea how to do. So yeah. So guys, is there anything else you want to share with us about the Freiheit or about yourself or anything?
Maybe we are both from KIT actually, so that's quite cool.
Especially exciting to see that the KIT team got the first solve on the G problem.
Yes. And we want to thank you basically for organizing this. Really nice that it's happening here. So it's also so close that we could drive here more or less by train directly, so super cool. Yeah. And the other thing is we always have the same application written out. Just go to freiheit.com and maybe you apply if you're interested.
Yeah, thanks a lot, and we also can support you on that. Thanks for the organizers and the amazing team behind. We with Jonathan are just two talking heads here, but there is a huge team of wizards that are working behind the scenes to make these huge systems of tons of laptops, balloons, cables, and papers working. I do assume that actually people who are organizing it, like volunteers, runners, and etc., they also fit for a job, you know, they know what is happening, and you need to solve pretty complex tasks to just set up the system like that. So yeah, I do believe they are also the people who could send you the applications. And yet, thanks for coming, and I hope we'll see you in the next editions of NWERC as well.
Would be very nice.
Yeah,
Yes.
I think so.
Thank you for having us.
Thank you. So we will now have a short break to change our scene, and then we will come back soon. So stay tuned. And welcome back, everyone. Now we have Pavel with us, who is the world champion of 2014 and silver gold medalist of 2013. And not only that, he's also a representative of JetBrains here with us today.
Well,
So
actually, as typically happens on recent ICPC event, I'm doing 3 or 4 roles in the same time. Like I'm coming as from company representative. I'm also coming to help with streaming. I'm also this time I was not preparing problems, but I was helping with testing them. So yeah, a lot of things happening.
yeah, also Pavel is the mastermind who sent us the intel on what is happening with the contestant submissions. So while you're here, we wouldn't know anything about it, but we will discuss it afterwards
we
anyways.
can-
So yeah.
Maybe someone from jury can send us something. We'll see.
So what do you
But-
think about the contest? How is it going so far?
Well, like it looks like teams slightly slowed down. So the last 3 problems indeed became a challenge for them. Also, I see some teams are struggling with problem B, but finally solving it, which is a bit annoying problem with a lot of cases in some of solutions, which took time to come up with correct way of handling all of them. But so probably we right now are back to the track with more reasonable timing for teams. So I don't think that the top team should solve H and I very fast. I can imagine solving everything in the end, but this happens. It's not something bad. It all like except where there are too many teams solving all, because then you're kind of comparing teams by time, which is much more variant and that's not good for like for first places or like being top 2 for world final selection, but also happens from time to time.
And while we were speaking, the Infinite Loopers teams became the top 1 team.
Oh,
In the contest,
they
they
solved B?
Yeah.
Okay.
First try. Very nice for them.
Actually, maybe they choose a better approach, which doesn't require that much case working. It also exists.
Yeah, I think they have quite a bit of time. So yeah.
Actually, like when we discussed problem complexity in before, my bet was that problem H is easier than problem G. Like it looks like it's not, for teams at least. But it looks like everyone agrees that problem I is the hardest of all. And
Yeah,
I think we don't
so.
even have any submissions on any of
I
them.
know on H we have a submission on H.
Oh.
I don't know what is it about. It's from the team on 80 on place
No,
82.
I haven't checked it. Oh, actually, it's just right now. Happened right now.
Oh, okay.
And they have some
it's
runtime
runtime
error. We'll see. Like these kind of problems can sometimes be solved by someone in the middle, because like it's not hard to implement when you get correct ideas. Like, but so this is problem which has these several runs, which is somewhat new to many of participants. These problems appeared from time to time in different places. I don't remember they ever appearing in official ICPC contest, to be honest. So maybe it's the first time this happening. So like this is kind of, at like some points there appears interactive problems when you not just read some inputs, process it and write some outputs, but rather need to interact with jury's problem.
Oh, by the way, we have a
With
statement.
jury's program. And here is you not just need to run your solution one, but you need to be able to run your solution several times and make these several times interact together correctly. So in particular, in this problem, like as you can see on slide, we have a set of tables, and we need to come up with some strategy which can move one table, and when run second time, move it back without knowing which table was moved in the first run.
And I guess also importantly, without now knowing if you are the second or the first one.
Yeah, and in this problem, you don't know if you are the first or the second. To be honest, I'm not sure if it really helps to know it, but yeah, maybe that can be additional complication. Like I think my solution don't really care, and I don't know any solution which care. Oh, we actually have a submission of on H from Cambridge team on 5th place.
Yeah,
And they are
that
kind
could
of
be good.
proceeding further. So yeah, in this kind of problem, you typically either work or not work. It's hard to come up with something which would work on half of the test cases. So now when they are passed a lot, I think it should pass soon.
And it seems like
Yeah,
that.
it
Yeah.
is.
Now the problem H is also opened.
Yeah.
Now it becomes more interesting and more tight. Two teams from Cambridge fighting for the top. Both have 10.
Yeah, it like
as
can also
expected.
happen that in the end, for Cambridge teams, like their competition within their university would be a problem, not for two first places. That also happens from time to time.
Yeah, exactly. And yeah, this problem is basically about some bit strings. So the statement is a bit more complicated, but yeah, we can narrow it down to just change the beat, the position of the chair. I think we will probably discuss the solution later. I don't know.
Oh,
if you
actually,
want to-
another Cambridge team submitted H.
Yeah,
Like Cambridge team are really submitting in a row this contest. Like they solved B in like 3 teams in 3 minutes. Three first solutions. That's a very funny coincidence.
yeah. And now H is probably in 1 or in 2 minutes. Yeah, exactly in 1 minute different.
I hope there would be another like Cambridge team solving it in another 1 minute because that would be too suspicious. But
I guess that won't happen because the other Cambridge team already
submitted G.
submitted G, and
But maybe they're working on 2 in parallel. Who knows?
that could happen, but
But typically it doesn't.
the problems are difficult enough that maybe they don't work all 3 on 1, but I would still guess that it would be a rare case that
Yeah.
it just happens
No,
now.
and also it typically happens when teams already have several wrong submissions. Then sometimes it happens. Okay, we found back on one problem and very soon found another, and then you're like -2 on one, -3 on another, quickly converted to 2 new problems. When you don't have any submissions, it also happens sometimes, but much more rare.
And now in the top 12, in the potential places with medals, we have only single team with 8 problems. I think it wouldn't be enough for them to stay there. Is the University of Amsterdam team that we had yesterday on our interview. So yeah,
Isn't it
let's
2
hope
teams?
they manage to
Yeah.
finish problem B.
Well,
yeah,
to be
doing correct
honest, I
tries.
still can imagine that it's now going a bit slower, but I still can imagine that you would need 10 for a medal.
Yeah, we have 2 more hours to go. I think
Yeah,
it's
and
more than
probably
enough.
a lot of teams would solve at least one of 2 of harder problems.
Yeah, it would be nice. Would be nice to see if anyone solves I. It's already interesting. Becomes
Uh,
interesting.
I don't know. Maybe they can, maybe they don't. I wouldn't be surprised by either. Probably it would be nicer if someone do solve, because otherwise we probably would have quite a lot of 11s, like maybe 5 or 6, and that's not perfect. But again,
By the way, while we're speaking about the solutions, do you know if there were any accepted in Kotlin? As your
I
representative of
think
JetBrains.
I saw at least one from a Belgian team from Leuven University. I didn't check it much after the contest beginning, so like there was a single team for the first hour. Like maybe they're a bit more now. I don't know.
Nice. Would be interesting to check in the closer to the end of the contest, like the distribution of selected languages or so.
Well, I don't think there are too much people using anything except C++. Actually, in this particular contest, there are quite a lot of Python submissions, but like team typically has Python as secondary language because it's very useful for small utilities. Like you can write some test generator on Python when you don't care about speed and something like that. So teams kind of know it and sometimes use it for simple problems. As for like Java or Kotlin, some teams do this. Many of them do this because of like they just have Java or Kotlin courses in their universities, and there can be their first language. Like you probably should not have you should have at least one person proficient in C++ in your team. And then the question is what works for you better, like language which would be slightly easier to debug stuff and probably slightly faster to write code, or like with more robust time limits, and also there is some value of writing on the same language for whole team. So like there are a lot of aspects to choose from. Like I'm writing competitions on Kotlin right now, and like in most cases it is fine with time limit. I would say like 5% of problems which has very tight time limit can cause some problems. Like, and typically this happens on more training contests where judges don't care that much because on like official ICPC competitions, judges ensure that all problems are solvable in Java. Like also it sometimes happens that when you are trying to squeeze solution which was not intended, it can be easier to do in faster language, but that's also like very luck dependent thing.
Yeah, it's like not intended to be so.
Yeah, I also remember from my few participations in the Kotlin Heroes competitions, um, like you notice it's slower, it's quite a factor, but not enough where I would say
I would
it's
say in my experience, like if problems set up well, it's like 10% slower or something like that, which is not like order of magnitude slower. The tricky part is Java Virtual Machine is like it's requires sometimes to speed up. That's why if you have a second, like if you have bigger constraints and larger and proportionally larger time limit, it would be simpler for Java-based languages to catch up. So like having constraints 2 or 3 times bigger with time limit 2 or 3 times bigger kind of mostly solves this problem. But
Ye-
jury needs to worry about that this to happen, which unfortunately not always happen. For example, on Code Forces rounds.
Yep, that makes sense though, because I also noticed that like every submission I make in C++ takes at least 15 milliseconds, and I assume that's just C++ stuff, starting the program, something like
I
that,
think it's just Windows stuff.
or maybe just Windows
Just
stuff.
starting process is quite slow on Windows.
And same for Kotlin. There I noticed. I don't remember anymore, like 100 milliseconds or something like that.
That's quite possible.
But that's as you said, if the time limit is like a little bit bigger and the constraints are a little bit bigger, that shouldn't be a problem.
Yeah, and it's also like Kotlin is not like designed for as any other Java language. It's not really designed for these really short runs. That's not something you typically do, like on production or like if you have your Android application, you don't restart it each 15 milliseconds. Uh, that's why that's is important thing, but not like that important thing. And yeah, and the longer you run the things, the less would be the difference. And to be honest, sometimes it can be even opposite because like Java Virtual Machine have this just-in-time compilation, which can see some patterns which happens in your program and optimize for them, which is impossible to do in advance because you just don't have this data. But this requires at times to run much bigger than a typical for competitive programming to benefit from this. Oh, it looks like we have one more accepted on H.
Yep, the Hasselblatt Institute team solved the problem H. Good job. And also, it's now required to have at least 9 problems to be in the medals. So one of the teams kicked out the University of Amsterdam from the top 12. I think it was Friedrich Alexander University. So yeah.
Oh, so we have 3 German universities in the top. From different universities,
For
I
now,
think.
yes, but we also know that there are some more teams from München, from the Karlsruhe Institute who are in top, somewhere close to the top, and they can quickly catch up. So yeah, it still looks interesting. We have still 2 more to go, and yeah, by the way, we have overview of our statistics. It looks like, yeah,
It looks like almost everyone solves problem F, except for like
except for
one
3,
team.
so I think,
Yeah,
yeah.
and a lot of teams solve problems L, K. Yeah, and
Yes.
problems B and E. I have a noticeable amount of team who tried to do them, but didn't succeed. Which is clear why for B, because it really has a lot of corner cases. For E, maybe just a lot of teams are trying to do some wrong solutions as they did in beginning. I can imagine that.
Maybe somebody just tries some formula or something like that.
Well, that's also some parts which comes with experience because, for example, yeah, you can come up with like, okay, it looks like there is a very easy formula, but then you can check like and see, okay, there are like 30 teams who tried and they didn't work for them. Probably it's not just easy formula, which I guessed. But yeah.
The bad thing is that when you realize that you are one of those 30 teams and you're like, oh, wow.
Okay, but actually, maybe it's not something very bad. Like you can risk a bit. You try to do this, and you spend like couple minutes of computer time, which is not too big. You either get very fast accepted and just ignore this problem and not spend any time on it anymore, or you get a penalty attempt. Okay, 20 penalty minutes. Maybe that's not that bad for potential benefits. So sometimes it's kind of worth it.
Yeah, I totally agree. And the challenge here would be to switch to another problem. Yeah.
Yeah. So the tricky part is to understand like, okay, I check in some random stuff. If it didn't work, I should throw it away immediately.
On the topic, we also just had like 5 correct submissions on problem B. So it seems like teams are now really catching up on problem B.
Okay, that's good.
Yeah, it could also be the case that we had a lot of incorrect submissions on B, and now maybe more and more teams starting to realize that their greedy solution is not working. So, okay, let's think about it more. Maybe they come up with something else.
Yeah, well, actually, I think that I don't know. Have you discussed this problem already? Maybe we can.
Not in
talk a
details.
bit
I think
more
we can show the slide of the
about it.
problem B. Yeah, and
Yeah,
dive a bit
because,
into the details.
Like
We
it
can
looks-
even discuss a solution if you want
Yeah,
to.
I can. So I know at least 2 different solutions, which one of them is kind of harder to implement, but have no much corner cases. So probably if you go that way, you would spend more time on programming, but then you probably would get accepted with first attempt. And some other solutions which are much easier, but you need to be very careful. So the problem is you need to find some amount of money made by euro coins, which means that you have 1, 2 coins and banknotes, which means that you have 1, 2, 5, 10, 20, 50, 100, 200, and 500 as possible amounts. You want to find a possible sum of n in such way that it cannot be divided into 2 piles of size n to the half. So for example, if you have 5 200 banknotes and 2 500 banknotes, you actually can divide them into equal halves, like a 1,000 and 1,000 of different types. And that's example of one of tricky cases, because a lot of solutions assume that if they have a banknote which has odd number of currencies, then you cannot split it into halves, which can be incorrect in this case, and that's probably almost the only case when it can happen, because in most of other cases you just did something wrong. Because for example, if you get 5 20 euro banknotes, then you can just replace them with 1 100. But unfortunately, you cannot replace 5 200 banknotes with 1,000 because you just don't have 1,000 banknotes. And yeah, so that's example of like tricky cases to happen.
I remember when the jury talked a little bit with me about this problem. One of the comments I heard a lot is this problem would be a lot easier if there was a 1,000 euro banknote.
Yes. I think with 1,000 euro banknotes, just a greedy approach of getting as much you can as largest banknote and then proceeding to next one, getting as much as you can this, and just check if any of them is owed, would become correct. But it's not correct because 500 and 200 are not multiples of each other. And actually, one of correct solutions I know is you can just try in both orders. You can either try to first get as much as you can 200s and then proceed further, or try to get as much as you have 500 and then proceed further. If either of these works, it's okay. But both are needed because of lack of this 1,000, which would be multiple of both of them. The other approach is based on the idea I told.
We can actually draw if needed, but if not, then
I'm not sure what we can draw here,
Yeah,
to be
okay,
honest.
let's
Let's just discuss it a bit. And another approach is based on idea. So that's one of the greedy approaches that can be done. In general, like you want to some greedy way have an answer and just check if it worked out. The other way is, as I said, as I made an example, if you have 5 20 euro banknotes, then it's much better to have one 100 instead, because like why would you give more choices to those who want to split? And you just get strictly less choices. And that's why for each of banknote, except for 200 and 500, you can limit how much of them do you need. So for example, you don't need more than 150, you don't need more than 420, and etc., etc. And actually, after you limit this, it occurs that it's not too much ways you can do things. So at this point, you can just brute force all these ways and see if any of them works. So the problem which this allows you to just brute force everything is you have very much choices of splitting 2 to 1 and 1, but why should you do this? Just don't do it, and then you have like a reasonable amount of choices, which you can just try all of them, and then the question is whether you can check if it's splittable to n to the half, and this, for example, can be done as like standard knapsack problem, or I think some greedy approaches also works here, but I'm not sure exactly. And I didn't implement it this one, but judges tell me that it should pass without any problems. And I think it actually was done by the first team, solved it, like this Cambridge team, which is now in the first place, but they messed up with these bounds and have too low bounds on 200. And that's why it was not really correct for them.
That's why they lost like a couple of minutes to another
Yeah,
team. Yeah.
and then, well, I was actually saying they lost more time on finding these, but still.
It's fun.
Yeah, but I also think this the second idea that you can realize that of some banknotes you just won't take too many because you can replace them by some bigger. I think even if it's a bit more to implement, it's a very elegant insight and very easy way then to solve it.
Yeah, I also think that if you come up with both, you definitely should choose this one because it's not that harder and much less risky. But the problem is you cannot understand that easily that it's an option and see like, okay, I have some greedy, it looks like working, let's try to implement it. Oh, I get wrong answer. Sure, I would fix something and it would work. And then you have -8. This happens sometimes. We have another submission on G.
Yeah, but they unfortunately current time
Oh.
plus time limit.
It's time
Yeah.
limit and runtime. Yeah. That's
Looks like
interesting.
pushing something.
Yeah, maybe they just fixed something and now getting time limit because I think they have wrong answer in before, or they just collecting all verdicts just in case.
I also I also think that they got wrong answer on G like a minute ago. So yes, they are really collecting all
Well,
the verdicts right now.
it's quite possible that they just have some out of bounds error and getting some random verdicts because something going wrong. It's also quite possible. I'm not sure what can be a time limit here unless they're trying to squeeze quadratic solution, which
Yeah, they may
sounds
be
strange.
trying somehow to squeeze something with some limitations. That's why it was wrong answer
Yeah.
at first and now time limit.
Yeah, maybe. So
Yeah.
I'll try to check when I come back to jury's room.
But while you are here, maybe there is something about JetBrains and their educational programs that you can share, by the way.
I'm not sure what exactly you want me to share. Like, JetBrains is working a lot with different universities. Like, we are supporting ICPC for quite a long time now. Like, we're looking for interns. There are our internships. We also have some special internships for ICPC participants sometimes. But they're not really much different. It's more like some like our internships are project based in sense like you're not just working in a team on their regular job, but rather having a separate project. And for some projects, we think, okay, these projects are probably would be interesting to people with ICPC background, and we're trying to mark them and encourage people to go to them if they have, but that's not a strict requirement or something. Like, we're also trying to help different universities. Like, we have some collaborations with Delft University, for example, in our Netherlands office, and with universities in Amsterdam. We have some collaborations with TUM, I think, in Munich, like in other offices also. And I think some students are trying to do their thesis as some projects they're doing with us. And also, of course, we have these free licenses for students that can. So all of our products are free for students and university teachers, as long as it's educational uses.
Yeah, I think that's really nice. I remember that I think I even learned some new programming languages while I was studying in university, just because you have an access to all of the IDEs of anything. So if you want to try anything, you can just use the JetBrains product with the.
Oh, I see. And we have one more 10 problem team.
Oh, by the way, yeah.
Yes, the University of Oxford just also solved problem G, and they're moving up to third place.
Okay.
Yeah, so it's really tight for the teams from the United Kingdom.
Yeah, which
Yeah.
probably means that as both problem G and H are now getting massively solved, it's quite possible that we would eventually see a team who solve both of them. Because all teams see, okay, these problems are possible, which kind of decrease chances of problem I to be solved soon. But maybe it's for good.
Yeah, totally, totally agree. Honestly, like, I think if anyone tries to do it in some soon and have a wrong answer, it could be really bad for them, because it's a pretty complex problem in terms of implementation as well. Not on comparing to H and G probably. So you can spend more time on something more complex, and then you're like, okay.
Well, it's definitely not a good choice from penalty time point of view, but I'm not sure, for example, if it's a good choice for probability of solving all three. Because if you have I already implemented, you can print it down, try to debug it in parallel with your teammates writing two other problems, which can be helpful, can be not.
I'm also thinking about the teams that are now not in medals but still have 9 problems. So everything from pi d plus control to Faust Fourier transform. Because if you are in that spot, maybe GHI is a bit too much of a jump in difficulty, and it might look difficult for them from that position.
Yeah, but then you see like G and dashes and H kind of looking approachable. I also think there was some submission in the middle of the scoreboard.
Yeah, actually
one of these
more than
problems.
one. Definitely H from
Not
21st
sure about
place, and yeah, here
submission.
from the AC University of Copenhagen. We don't know yet what is it
Okay.
about.
But no accepted. Okay, I think there was accepted on H somewhere in the middle, but I was not sure.
I think we may see something like that closer to
Yeah,
the end of the contest,
I
maybe
can imagine completely.
during the unfreezing ceremony. Yeah.
We'll see. So you're also streaming the closing ceremony with Resolver and everything else?
I think so. I think that everything should be set up. I think yesterday we also have the opening ceremony, live stream, and
Nice.
today it should be for the closing ceremony. So yeah, for everyone who is watching, I think it would be a separate YouTube link, so it would be a separate live stream. But anyways,
It's on the same channel, so should be easy to find.
yeah.
And
So click
also-
the subscribe and like button.
And also it should be like in an hour or something after the contest, probably a bit more.
I'm not sure actually about the schedule, but maybe you're right. It should be something about that. It's also usually starts with some additional words, and while everybody's gathering, and then it takes quite some time to get to the top, but in the end, you need to wait and see who will be the leader.
Yeah. Well, I think they typically try to make it faster in last times by mostly like just running through teams until we get to teams solving like 7 or 8 problems. It also kind of helps not to concentrate on teams that did not so well, which happens sometimes with some teams. And also, yeah, like spending too much time on attention of teams who didn't did well is not a good thing anyway. So it also helps with running faster.
Yeah, and also there is a sponsor team from the JetBrains who are working on the problems, and we know that they're
Yeah,
doing pretty well.
yeah, and I probably could be at this team instead. And the problem is at the point when like the idea of making a team appeared, I was already agreed to help with problem testing, and like you cannot both test and problems and participate. It would be nice, but not how it should work.
But they're doing pretty well. I think they
Yeah,
had G, right, if I remember correctly.
yeah, that was like around an hour ago, I think. I'm not sure what exactly. I think they had some problems with B, but yeah, should be approachable at some point. There's also a very strong jump trading team. Like, and Albert Blanc is also doing quite well from what I think. Well, actually, there's like a fourth sponsor team from some local sponsor.
From Freiheit, yeah,
From
we have them
Freiheit. Oh,
previously
yeah.
on the
And I think
stream,
they was
yeah.
also doing quite well with 7 or 8.
Oh, really?
And,
Because when we
like-
had guys from there with us, they told that, oh, it's
Yeah,
not
well,
going
they
well.
was not like in the medals now, but still, like I think they had 7 last time I checked.
Yeah, I think that's very decent considering the fact that when you are not doing it every week, every day for practicing,
sure.
the 7 problems is definitely very, very good, strong result.
Sure. And like the same for like I think most of sponsor teams, like these are people who didn't doing it right now very often. Like I don't know, I discussed with team with jump trading. I think they basically like okay, they write one training with each other just in case, but that's probably was the only competition they wrote for last couple of years. So yeah.
And what do you think? How much like training and efforts are typically needed from the top teams based on your experience? Like how to nail it?
It can be really different. Like it's becoming bigger and bigger from time. So now, if you want to be at the very top, you really need to train a lot. Like, but very top is very like unclear, have unclear bounds. Like if you just like I mean, if you want to like participate in a race for like gold and world finals, then probably it's just a full-time job, effectively. Like when you want to like participate for just passing for world finals, it still requires a lot of training, but maybe not that level of commitment. Like maybe 1 a week should be enough for that. I like as a guess. I'm not sure, but it also a lot depends on specific people. So how much did you do previous year?
I just wanted to talk about Infinite Loopers, but I can
Oh.
also tell our team experience. I mean, it varies over time, but yeah, for us the general pace was like 1 practice per week as a team. A lot more during training camps, obviously, and also, I mean, there are a lot of code forces competitions and practice on code forces and so on. So I would guess that the total time per week is more than 10 hours. But I also know that the Infinite Loopers, I don't know how much they're practicing right now. They're also on screen right now in the very back. But I know that before the last NWERC, they were really set on practicing a lot, and they did at least 2 5-hour contests per week.
Like back in 2014, we did 3 per week, but that's at this point it's becoming a full-time job, as I said. Like I think that actually like 2 guys from jump trading team was on the same team back in probably 2017. I'm not sure, maybe 16, like somewhere around that. And I think they had even more. But yeah, that's like when you really competing for the like first places. And I'm not sure like is it the most useful way of spending your time in university sometimes. Yeah, and also speaking about training camps, by the way, another thing which JetBrains is doing for ICPC, we are organizing a training camp in Paphos before, like it's mostly targeted for teams going to World Finals. Like I think there is no specific dates confirmed yet, but there is some plans to organize it again in this summer. Without like, I'm not sure about specific plans like dates and anything else. It should be known closer to European Championship in February.
And as someone who has been there 3 times, I think, yeah, I can recommend it. It's also very nice, not just from the, I think, generally pretty good selection of training contests, but also in the evening when it's a bit cooler outside, not like in the 30-degree hot sun. But when it goes a bit down, it's also quite nice to go outside, visit the port, and so on.
And speaking about our other educational programs, so we have 2 programs in universities in Europe, which are significantly supported by JetBrains. One of them is in Neapolis University Paphos, which is also used as a base for organizing these training camps. And another one is in Constructor University in Bremen, here in Germany. By the way, there should be a team from Constructor University somewhere. I'm not sure how well are they doing. Maybe we can check.
I'm pretty sure that I even saw at least 2 of them.
I think even 3, but...
The first one is in the 28th place right now with 7 problems. And the next one is very close to them with 7 problems as well.
That's not that great, but still nice result. This probably wouldn't be enough to pass to European Championship, but maybe if they solve 1 or 2 more problems in remaining time, this can be enough.
Yeah, they don't have C and they don't have B, so it should
C is
be
definitely approachable.
Yeah,
B can require some time, but still. But other teams are also not waiting, so we'll see.
Yeah, but they're pretty high. They're basically the top 1 team with 7 problems right now. So they have the least amount of penalty and supposedly the most amount of time to implement something else. It surprisingly took them a lot of time to solve A and J, which kind of
happens. It's hard.
Yeah.
Oh, actually, they just solved the 8th one, I think.
Nice. Looks like that.
So we'll see. And the Paphos team are participating in another region. I think they are in southeastern Europe.
Yeah, I just want to say, because earlier I made the comment that it might be hard to get into the medal places if you are not already in it. But I was already proven wrong by a team who got problem B and just has penalty good enough to now be inside of the medal ranks.
It was the University of Amsterdam, right?
Yeah.
Which we had yesterday. Yeah, I think they did it pretty like smoothly without any issues in the beginning of the contest, because like 8 minutes, 14, 17, 23, the first 4 problems just super quickly.
Yeah, and as we know, they have a special person who are working on hard problems from the beginning. so we would see whether it would pay off in this type of the contest.
So maybe we will just see H, G, I, 1 after
Hey, just I in 15 minutes. Well, it's not applicable to this kind of contest, but for example, in World Finals, you get a money prize for each first to solve. So sometimes there are teams who, typically that's teams which have 1 very top participants and 2 not so top participants. They are going and they are not really competing for medals, because even if you are really top 1, it's hard to get a medal alone. Then there are sometimes just skipping several easy problems and going to first to solves to collect some money prizes, which is probably not intended thing, but can happen.
I actually know that in my team we had a first to solve, and the person in our team reading from the back just skipped, I think, the first problem in the back just to find another easy one faster, and it actually worked out.
Yeah, like I think in general that's not what you should optimize on the contest, but sometimes it can be nice and not too bad.
I'm also seeing right now, okay, the submission on H is already a wrong answer from the 3rd Cambridge team, and now they've tried
have
both.
2 problems kind of solved for them, probably. At least they think they solved them, but have problems in both. But this actually can mean that if they fix both soon, they can go at 11. But they are not having really great penalty time. So even if they get 11 first, I think other teams would be easily able to overcome them.
Yeah, I think for them it's kind of a tricky situation. I remember
I
myself in
s-
such case that
I think at current points, their best bet is just completely ignore penalty time and go for solving 12.
yeah, I kind of agree with that. It's like when you have this situation with 1 hour and a half to go, you have two problems that have wrong answers. You probably just sitting and trying to find the bugs in the code. The third problem is super hard and you don't know how to solve it. Your maybe third person is either assisting one of the two who are working on G and H, and yeah, that's not the best situation to be in because you, with every minute, you are losing the time to basically finish like debugging and fix the bug, and it may turn to be that you just have incorrect solution or you cannot find the bug and then you just stuck with two incorrect submissions, and yeah, that's very frustrating because you can't just, you can feel that you're super close with passing one of them, but until you solved it you cannot just switch to I because you understand that you probably must solve those two.
Yeah, and also it's kind of problematic that for the third person, because what should you do? You should solve I, you should help on one of them, you should help on another of them, you should try to help on both. Like all of this is kind of reasonable, but
And also they have a pressure that they have a lot of other teams from their university who are like on the first and on the second line. So it seems that they are close to competing for the world final spot or for the EUC spot, but now with two wrong answers. So yeah, not the best, easiest situation to be in.
we'll see how they would handle it.
I think in such situations it's helpful if you have some dedicated person in the team who is like saying just we're doing this, and then everybody just believes
it's
him.
actually an interesting topic on how you make decisions, and it can differ from team to team. Sometimes there is a one person who leading. Sometimes you can go with more democratic approaches. Like each has its own benefits. Like, and in general, like it's really important to be able to estimate on how like bad you are in different problems. Like how bad is your solution on G, for example, in their specific case, because they have like both runtime error, wrong answer, and time limit, which may mean that they just have some stupid bug, but also may mean that their solution is just completely wrong and they're doing something totally incorrect. And it's hard to estimate from the team point of view what's going on.
Although it would be nice, now that they were so good at collecting verdicts on this problem, if they could also collect the accepted verdict.
Should they also collect compile error first?
And memory limit.
I'm not sure if we have memory limit, to be honest.
Really?
I think it's reported as runtime error for some technical reasons in many systems. Like basically on Linux judging systems, it's hard to distinguish memory limit from runtime error because basically both is your program crashed and you can do some guesstimates by the fact how much memory it used before it crashed, but still you cannot reliably do this. And that's why some testing systems decide to just not trying to do this and saying, okay, both is runtime error, sorry.
But I know that DomJudge actually has two more verdicts it can give, namely no output and output limit exceeded.
Yeah,
It also may exist some security violation verdict, or no?
probably.
But
Like
we
it's
shouldn't
not
try this one probably.
specified. Like it can be like different. I think in most official competitions, like they try to move everything to some simple verdicts. Like there is another school which prefers to give as much information as you can. For example, I saw some systems which for interactive problems support separate query limit exceeded verdict or something like that for specializing what exactly is wrong with your solution. But yeah, that I think typically doesn't happen. And as I remember the setup here, it's just query main verdicts. So you only get its wrong answer, time limit, or accept it, or you did something completely wrong and probably should just resubmit for correct problem or something like that. Okay.
Among the problems with the teams who are following, we also have the submit one, who are now have 8 problems solved and have incorrect try on B. So probably they will manage to do it and be somewhere closer to the top. Yeah. So, yeah, go on.
Although I would guess if they still get B, I would hope that it's enough to get into the European Championship. I mean, my guess is that 9 problems are going to be enough, but I heard that you had another opinion earlier that you think it's going to take 10.
We'll see. I'm not sure. Like from what it's going, it's probably for how it's going. I think it should be 10, but yeah, who knows? They currently have 7 teams with 10.
Yep, I think it would be 12 close to the end of the contest for sure, but then maybe it would be only on unfreezing time because we have just half an hour to go. So yeah.
Yeah, and also we have several Cambridge teams, which also brings it lower because we have 12, and we also have not 12 but 13 universities. Which, so my bet was not 10 for European Championship, but rather 10 for the medal. Let be, but
That's good
yeah,
point.
but still, like you would need a really good time with 9 if you would want to have it pass to European Championship with 9 and be not from Cambridge.
And 10 for medal spot does look actually more and more likely. And it seems like Cambridge, yes, Cambridge has, or I say Cambridge as if that distinguishes anything. The open parenthesis team from Cambridge, who has tried both G and H, has solved H.
And they're going only to 7th place. But again, if they fix G, it would be they would be first. But the question is for how long, because their penalty is not great.
It's also interesting that we have right now almost the same amount of teams with 10 problems as with 9 problems. So it's not as like, because the G and H are approximately the same of difficulty. Oh no, yeah, it's basically just super hard to crack any of them. And then a bunch of teams with 8. Okay, with 8 it's again approximately the same. So yeah, just
Maybe we can see a scoreboard in a stream, because otherwise we're discussing it slightly out of. Yeah, thanks. So yeah, as I see, we have 8 teams with 10 and 10 teams with 9, and then a lot of teams with 8.
yeah, everything is super close. By the way, maybe we can discuss some more problems for now. I know we have 3 hardest ones, so that we can maybe still skip for now. I know we have C, which we haven't discussed yet, which is kind of interesting.
Which one is that?
It's about the graph.
Like about Taylor Tour.
Yes, it's to find. You're given a graph, and some of the edges are bridges, and your task is to find one tour that starts and ends at the same point, and you want to walk over every bridge, and you don't want to take any path or any bridge twice. And you are also told that you have to minimize the total length of your path. And yes, it's also guaranteed that your shortest tour, not shortest tour, that one tour even exists. And I would say this problem is a bit tricky in its wording, because they tell you to find the shortest path, but actually there only exists one path. Or what I should say additionally, you are also at some point given the constraint that if you take all of the bridges out, the remaining graph is just a tree, and that's what makes That's what makes the path you have to take unique.
And we can also draw a solution, right? If you want to explain
Yes.
it in a bit. If we can have our drawing board, it would be amazing. So now we know the problem statement. So yeah, basically just to draw a bit of graphs, because yeah, it's...
I'm gonna start just
Yeah, yeah.
drawing a bit and finish the explanation once we have.
We have one more submission on G from Teams and Medals.
The one with the ZFS in the name. Oh, now we can see it. Yep. Yep, nice.
Okay, so we have some tree. Or is there a way to change the color of the pen on this? If not, I'm just going to use squiggly lines or something. Okay, then. Oh. Oh, okay. Let's use this one. Okay, so we have some tree, which is our road network, and now let's consider one very simple case. We just have one bridge, like this. In that case, I think it's very clear what we want to do is just to take all of these roads to basically close the cycle. So we are walking over the bridge, and then we are using the unique path that exists over the tree to get back to the starting point. Okay. Now the interesting question is, how do we handle if we have, for example, this bridge? And in that case, if we just add another cycle, we have a problem on this edge over here that is used twice. And we are not allowed to do that. We should only use every edge at most once. But the nice thing is, instead of using it twice, we can also just use it 0 times. So these two things just cancel out. Maybe intuitively we can, for both cycles, decide if just one cycle exists, we can decide if we want to walk it clockwise or counterclockwise. And if I just make a small image here of that's I can't draw right now. Okay, I was too close to the edge probably. If I have 2 cycles, if I choose my 2 cycles like this, it's very obvious that I would walk this edge down once and then back up again once. So I can just the pen doesn't seem to be working all the time, but I can just cancel this. This part just cancels out, and so you're left with just one cycle in the end. And the jury was nice enough to even guarantee to you that the path exists, so you don't even have to check if it's just one cycle that falls out of this or if it's more. Now the last problem is you kind of have to figure out what actually are the edges that you have to take, because you still have to find the length and have to sum them up. And here the idea is simply you take an edge if the number of bridge endpoints below it is odd. So for example, we have one bridge endpoint here, over here we have 2, and over here we have 1. So we have 1 bridge endpoint below here, we have 3 below here, we have also 1 here, 4 here, and 1 here, 1 here, 2 here. And if there's an odd number on a vertex, you take the edge above it. You should set some arbitrary root before. I've used this one. And the nice thing is also the root will have an even number, so it's also logically consistent because the root also doesn't have an edge that's going out upwards. And like this, we have a solution for problem C.
Yeah, looks nice that you found how to use colors. Now it's much more understandable than what we were drawing previously. So yeah, that's pretty nice problem about some graphs, DFS. Requires some thinking.
Also, like this idea with finding with cycles that cancel out, and also this idea of taking an edge if below you is an even or an odd number of vertices is, I think it's something top participants have already seen in some other problems.
Yes, and actually there is some more generic techniques even here. There is like some linear algebra thing on the graph, which I'm not sure how wide is known now. It was like popular for some time around like 2013, 2014. I'm not sure how popular it's now. That basically, like if you see on the like sets of edges which forms like these several unions of several cycles, they in some sense can be arranged into vector space. And basically what's given in this problem is exactly the basis of this vector space, which probably too complicated for this problem and you don't really need it. But if you already know this idea, it actually can simplify you this problem a bit, because like, okay, I know that it's a vector space, I know that all the compositions in it are unique, and yeah, I have just unique solution, and thanks to Jura, I don't need to even check if it's correct.
I even learned about cycle space at the Paphos training camp in 2023, I think. So it's, yeah.
I think it was first problem I see about it was like from on some Perturmeter chef contest, like back in 2012 or something like that. And at this point it looked like it's complete magic, but yeah, when actually people explained how it works, it was not that magical.
By the way, we completely forgot that above us, behind us, sorry, we have the great stage set up with the nice JetBrains advent calendars, or just nice candies that were shared with all of the participants. We also had a bunch here in the studio.
Maybe you can show one of them.
Yeah,
closer.
yeah, for sure.
So yeah, that's some kind of gifts we're giving to participants. So here you can see, so I think each participant gets one on their table on the competition as a kind of surprise. It has probably, so it's intended to be kind of advent calendar. It's not like what you need on the competition, but maybe someone would decide just to get it back to their home and use it as actual advent calendar. But here you have like a chocolate per each problem, and some extras, like if you need an like urgent bug fix, there is a bug fix chocolate. Not sure if it would help you, but at least it would be nice.
Also, like there's a little bit of a stand back here, and I can see a little bit into the advent calendar, and I see that the chocolates also have some small patterns or some small figures on them. Do you know what they are?
No, I don't know.
Okay.
I'll actually trying to make some special merch for ICPC events. So I think, for example, in our booth here, you was able to get some fridge magnet with Karlsruhe University and some NWERC symbolics, for example. And so we are even doing this for specific events.
Yeah, that's
Also
nice.
some other stuff.
So probably we should
Oh.
take a short break and taste the chocolate from one of the advent calendars.
Maybe
But while we are doing so, everybody stay tuned. We will come back in a couple of minutes. And thanks, Pavel, for coming to our stream and telling us about problems and about JetBrains. Yep. And welcome back, everyone. And now we are joined by Paul from the jury team. But before we will be discussing some complex problems, we should say that we now have 2 teams with 11.
Right. We had it quite often today that just before we go into a pause, some team does something amazing, and it has happened again. Bra Open from Cambridge was the first team to reach 11 problems. They solved G just before the pause. And also during the pause, the Trinity team solved problem H. So we now have 2 teams that have 11 problems.
And by the way, while we were speaking, there is first submission on problem I from Hasse-Plattner Institute, seems to be. Okay, and it's from Cancer and the 10th test case. Unfortunate, but could happen with such kind of a problem. Yeah, that's really dense right now. In the top, we have 3 teams from Cambridge in the first 3 rows. So they are basically competing in time between each other. And while we have 1 minute before the final hour, we should explain in a bit that just in 1 minute, we will stop receiving updates on the verdicts, because it will be the freeze time. So for the last hour of the contest, we don't receive any updates in the scoreboard. We just see who tried what. We can obviously try to look at the cameras and try to see which team is still trying to implement something, but no specific results. So there will be some uncertainty up until to the end, who qualifies, who win it all, who get medals, which would be pretty interesting to watch. So stay tuned for the award ceremony. And yeah, just 15 more seconds to go.
Yeah, and we as a jury are really happy to see that teams apparently were able to, or were not able, to full solve the entire set before the freeze. Let's see, there's 3 seconds to go, but I don't see any submissions coming in right now, and now we're actually inside the freeze, so yeah, looks like there will be some suspense left. I think the top 2 teams should still have enough time to at least attempt problem I. We'll see whether they actually manage to solve it. I think that would probably mean that they win, especially if it's the leading team, because they are so far ahead on penalty time. Yeah. And I mean, they might hope that just no one solves I, because in that case, they have already won.
Totally agree. They did it so clean in the beginning of the contest. Like just 1 wrong submission in B, which is like understandable.
Yeah.
To get it. And for the I, but I think it's also interesting to see the Hasse-Plattner Institute team with 1 try on I. So if their solution is kind of correct, but maybe with some corner case missed or something like that, they have enough time to debug it. But as they have almost everything implemented, they are maybe debugging it on a paper, which means that another team member can solve G in the meantime. So it's also good for them.
Yeah.
If I is correct.
And I'm a bit curious now that we're in the freeze. My guess is also that we're not getting any updates from the jury anymore and won't actually know if they just are missing a small detail or not.
Yeah, so we won't be giving updates. And I mean, given that this submission was before the freeze, maybe one of the judges or analysts can take a look at this one, so that I would still be totally fine with. But yeah, I don't know. I mean, I for sure, there is at least one very tricky edge case that you can forget. So yeah, maybe it's just that one, but there's also a lot of other ways in which you can just mess this one up.
And just in terms of even the implementation, if everything is correct, it just can make something wrong because it's probably more complex to implement than G and H. So
yeah, I think this is by far the most implementation heavy problem we have in our set, unless you're over complicating something like B, which we've seen some submissions that were well over 100 and even approaching 200 lines of code. Yeah,
definitely not from the team on the 7th place who managed to fit single line DFS into the team name.
Yeah, I don't know. I mean, there were some problems where DFS could be used. Maybe they actually had that exact line in there. I mean, I guess they can just copy paste it from the DOM judge scoreboard, right?
So now, like, if you are out of the lines in your team book, in the handbook, you just put it in the team name.
Yeah, looks like they found a loophole there.
I was also wondering if their name is already pushing the character limit for team names, or if there even is a character limit for team names?
I'm gonna assume there is, given that this ICPC tool has been used for so many years at this point, and people are bound to have tried, at least. So maybe this was instituted at some time. I remember a few years back there were a lot of special characters still allowed, and especially a bunch of emoji. And these days, some emoji are still possible, but it looks like it's sort of tuned down a bit these days.
Yeah, we were discussing yesterday during the test session how it's sometimes hard to announce the team name.
Yeah.
So we usually just go by the university name and clarify it only in case of multiple teams, because then you just have some complex names that you don't know how to read, and yeah.
Yeah, maybe the teams don't even know how to read.
Yeah, the silent was really funny for a long time with only using owl emojis.
Yeah, and then the only differentiation was that, yeah, we're going to use square brackets, and those guys are going to use braces or angled brackets, and then it's always a mess. But I mean, it's also fun. It's very recognizable. You always know which university this is just from the team name.
By the way, should we maybe discuss one of the harder problems, like G or H?
Yeah,
What do you prefer?
absolutely. Let's do it. I'm fine with either. Let's do G, because we were talking about doing this one, and that was the one that was solved by the top team just as we went inside the freeze.
Yep. So now we have this slide with a statement.
Yeah. So this one is actually a callback to an old NWERC problem from one of the BAF editions. So it's about the same group of friends who are going mountain climbing. And want to take a photo where they're arranged in some order. But of course, the setup here is slightly different. We're not going to just copy a problem straight up. But still, so the way this is set up, we have a permutation of numbers, which are just the heights of these people. And we want to rearrange them so that the new permutation that we get is what's called here as mountain shaped. So there should be, when you start going from left to right over this permutation, the values should steadily increase until you reach the maximum, and from there on it should only decrease. And of course, any given permutation might not satisfy this constraint, like the one on the left clearly does not. And the question is, okay, so some of these people are going to stay put where they are, and some of the other people you're going to allow to move. And the question is, what is the smallest number of people that you need to tell to move so that you can actually satisfy this constraint about the permutation? Yeah, so that is the problem.
Okay, just a short comment, also for all the problem writers out there. So the problem author is my teammate, or I guess former teammate. And I even remember doing this contest with him and reading this exact problem. And what really makes a problem memorable is like the story around it. I remember this exact story because of the no weather too extreme recreational, I don't know what's C stands
community or something like that.
Something like that. So the stupid NWERC
acronym, yes.
Joke there. Yeah, it's so fun stories really make your problems memorable, and also that helps if I need to recall a technique I've seen. I can think back, oh, it was this and that problem. So please keep writing funny stories.
Yeah, that's awesome. I mean, it was especially nice that we were able to create this callback to the old problem, given that this is a very similar kind of setup, even though the problem itself is completely different, of course. So yeah, we were really happy with that. I think Markus from the jury was the one who was preparing this problem, and he also remembered this problem. I think he participated in that contest, actually. I'm not entirely sure, but at the very least, he still remembered this, and I was like, yeah, that is the perfect opportunity to do that. Yeah.
And actually, when I initially read the problem, I didn't get the statement right. I don't know if any team did it as well, but maybe it violates the input test. But I thought that you just need to minimize the number of people that you reorder, but you don't care if they stay on the same place or not. And then the problem is much simpler because you just do some increase in subsequence on the prefix, decreasing subsequence on the suffix, and then just basically take the optimal point in the middle,
Mhm.
and that's it. But it turned out to be not so easy problem, and turned out to be one of the hardest one. And I was like, what? Why? And then I realized that, yeah, the rookie mistake of reading the problem statement incorrectly.
Yeah, so the key thing to look at here is really that if you select the people who are going to stay put and you select the people who are going to move, then the people that are going to move, they vacate their spots, but you don't do any shuffling around of the other people, so they don't close any gaps or anything, and you really need to reinsert the people into the exact slots where there were people before, and that's what makes it much trickier as a problem. Yeah, so shall we go a bit about how you can actually solve
go forward
this?
to the real, true, actual solution of the problem in this more complex statement. So
Okay.
we have our drawing pad, and you
Yeah.
can be here the pencil, the rubber, and then change the color if needed.
Okay, yeah, let's see it. I'll figure it out on the fly. So let's see. So if this problem had smaller constraints where you were would you have been able to do some quadratic submission, then this would be much simpler because then what you can do is, okay, I want, say I have the numbers, say I just want to create a permutation that is in this mountain shape. Then what I do is I take the numbers from 1 to n, say I have n is equal to 10. So then I need to arrange these 10 people, and I start from small to large. And so the smallest person I know needs to go either to the very left of the sequence or to the very right. So let's place them at the very left. And now we know that we have a smaller version of the same problem, because now we have this remaining interval, and we are going to have to place person 2 either at the left of that remaining interval or at the very right. So let's place them on the right, and then we just continue. Let's say 3, 4, 5. Let's maybe do some more here. 6, 7, 8, 9, and then finally 10. Or any other solution like this. So that is how you create such a permutation in general, and having this similar substructure thing should already make all sorts of alarm bells ringing in your head about, oh, this seems like something that can be done with dynamic programming. That's exactly what is the case here. So this would lead to a quadratic time dynamic programming solution, where basically you say, okay, I have this subinterval on which I want to have as few people move as possible. And then this is just the values in my DP. So I have a dynamic programming table that has I and j, and then we say that if we have the subinterval that starts at person I and ends at person j, then what is the least number of people I need to move in there? And because I always assign the smallest person to either go into spot I or into spot j, this value only depends on the values for I plus 1j or I and j minus 1. So you have a constant time per state, and therefore the runtime is overall quadratic because there's a quadratic number of states. Now, of course, this being one of the hardest problems in the contest, it's not as simple as that, and you actually need to be a bit smarter. So let's see, what's a good way to just wipe the page here? Or, oh, we can move it. Yeah, that works as well. So let's move it.
Note, if you move it there, it's not moved on stream. That's something that has to be done by the stream people behind the screen.
Okay, so I will just continue below what I wrote, and then the stream people can just move it along. Yeah, perfect. So let's do it. And if you actually look at these DP states, what's happening is that for each state transition that you do, it's either, okay, I use the person that is exactly in, I can actually place the person that I next need to place. So if I know what the interval is, I also know what the smallest person that should be in that interval is. So then I know either I can place that person there. In this case, my cost is 0. Or I need to place someone else there. In this case, my cost is 1. And the key observation to make this fast is that the situation where you get cost 0 actually only occurs in very few of these states. And that is what leads to a smaller runtime, because then you can actually think of this as, okay, I have this state ij, I go to i+1j or to ij minus 1. So what I do is I'm here in my state ij, and I either go to i+1 comma j, right? So this would be I increasing towards that direction, or I go to I comma j minus 1. So that would be j increases in this direction. So because I'm decreasing j, I move to the right.
To the left.
To the left, exactly. So, right, and then let's say this one is actually cost 0 and this one is actually cost 1. And like I said, there's only a few of these zeros. So if you sort of draw a bigger picture, then what is happening is you get this sort of triangle in which your DP states live, where here you start at 1 comma n, so the entire array, and here you arrive at the states where it's just a single person left, where you then need to place the tallest person. And you sort of navigate from this top left to top right corner to somewhere on this diagonal, and you do this doing some sort of zigzag path. Right. And now, as we recall, there's only a few of these state transitions where there's actually cost 0. So that means there's a few transitions in here where you actually have cost 0. So that means there's only a few of these arrows that you can pick up to improve your solution. And you want to pick up as few as possible, no, as many as possible, because then your score is as low as possible because you got as many zeros as possible. Yeah. And now, once you model the problem that way, there's sort of two ways to go about this. I will explain the one that I understand a bit better, which is that this actually can be reduced to the longest increasing subsequence problem, interestingly enough. So you are kind of on the right track. Yeah, because basically, let me remember, this is a bit technical now, so I'm not sure I'm going to get it exactly right, but basically the interaction between these arrows is, okay, when can I go from one arrow to another? Then that means that I can only do this if this arrow is somewhat to the lower left of the other arrow. And so you can sort of see that this means it needs to be that I can reduce it to LIS. It's just a bit tricky because it's not just points that I need to move between, but these arrows, and you then need to be a bit precise about what to the lower left means. Right, you could have an arrow here, and then depending on how you model these, you could actually do some off by one arrow and mess it up. So this is a bit tricky to get right. I'm not sure if there were many incorrect submissions. It doesn't seem to be the case, right? There was one team that needed 3 submissions. That was the Infinite Loopers team, and the others got it on the first try.
Although we earlier had a look at the error that the Infinite Loopers had. It was like they had the input array A and then wanted to have the inverse array, and they just for some reason had the line which initialized this inverted array commented out. Yeah. This is what we've already seen earlier, and actually the second error they had up here is, we haven't shown it on stream, but it's even a tiny bit funnier, because instead of writing x is greater or equal to 0, they wrote x is greater minus 0. So instead of an equal sign, they wrote a minus sign. And that's also, I guess, somewhat tricky to pick up, because I guess the minus doesn't do anything.
Yeah.
So the line basically becomes x is greater than 0. It's like the equals is missing. And I can get that you would just, that's just a small error that might not be caught by samples.
Yeah, so most other characters you could put there instead would just result in a compile error and you notice it right away, but this is actually really, really devious, yes.
I was also wondering if there shouldn't be a compiler warning if you put -0 in your code, because it looks kind of suspicious. And especially minus then a space, and then a 0.
Yeah. Yeah, I'm not sure. I don't think I've ever tried what happens if you enter this into a compiler, whether there's some flag you can activate that will warn you about this. But yeah, very tricky.
Are you done with the solution?
I think I'm done with the solution to G, unless there's more questions that you guys have on the spot.
I just wanted to comment on seems to be okay. Because they have now put a second submission into I, and we obviously don't know if it's going to be correct or not. But we can always speculate a little. And I would personally say if it's not correct, we are probably going to see just another attempt at some point, because you might as well try so close to the end. One more problem is more worth than however much penalty. But if you don't see another submission on this problem, then I would even assume that this is probably a correct submission.
Yeah, I mean, sometimes teams do some metagaming where they're like, yeah, we have this solved now, but we're going to leave people in the dark and we're just going to keep submitting on that so that they think we haven't solved this. I'm not sure whether that's actually beneficial, other than, yeah, you can troll people this way.
Still tricky though, like in the worst case scenario, they like submitted it the second time, got again wrong answer, printed out the code, somebody said like see to debug it, and then they switched places to implement G, and then when probably they exchange places once more, there would be a person who's like, okay, I found all my bugs in my I implementation, let me fix it. It's like 10 minutes to go, the person tries and got the second incorrect submission, or even after he just don't have enough time, or he didn't manage to find the error. So it's still tricky. It could be the case that it's just one try during the freeze time and it's not accepted. But yeah, it's probably more common to face a situation like you mentioned. But yeah.
I mean, at this point in the contest, they should probably also decide between G and I and just put all their energy into getting one of those accepted, because getting both seems quite unlikely given that there's only 40-ish minutes left in the competition.
Although, if they got it correct, I would assume that G as a group of 3 seems manageable, especially because they probably didn't have all their people working on I before the freeze, so they might even already have some progress on G.
Yeah, one definite advantage of G over I is that, especially if you find this longest increasing subsequence approach, this is very short to implement. And you need to be a bit careful, but it's also pretty easy to test this locally. So even if you get it wrong on the first try, I don't think this is the kind of problem where you just get stuck in debug hell. Whereas I very much is. So if they are close to G, then maybe switching is actually a good call, and then they can still return to I afterwards, but we'll see what happens. I mean, maybe they even solved it already. In that case, they're definitely switching to G now.
Yeah, that would be super cool if they managed to do it, because yeah, they also solved Ash already, and they have not so many time comparing to other teams. And then being able to solve it with 1 more hour to go is like really impressive.
Yeah, it would also make the scoreboard reveal that much more exciting, because then they move up, but we're still not finding out what some of the teams in front of them, which I'm very certain will do submissions on the problems they haven't solved yet, are gonna do. So.
Oh yeah, by the way, we have right now on the stream the like most positive scoreboard we can, I suppose, where each of the submissions are marked as accepted, but still the places probably are shown in a way like it's not accepted, so it's a bit shuffled, but anyways.
Yeah, so the left-hand column shows their current positions, and to get optimistic positions, I guess you need to count.
Yep, yeah. But no, there is not so much things going on right now in the top, honestly. Like, there just a few teams tried something. The University of Cambridge opening bracket team tried G. They probably could do it, but they've tried already for several times. So hopefully they just have some bug that they managed to solve, because like 3 tries
Yeah,
with the
there's
correct
there's
idea
a
looks
there's a
suspicious.
considerable gap between the last 2 submissions, almost an hour or
Yeah,
more than an
yeah.
hour even between the
So
previous and the
let's
current
hope that
submission.
they completely rewrite it, but maybe also the computer was occupied with some other tasks like
Mm-hmm.
H or I. So yeah, they didn't
Yeah.
have time to fix it. Yeah.
Oh, and I think we are now getting a scoreboard if everything is rejected, but that should be just the current scoreboard, I guess.
Yeah, once you're in the freeze.
Yeah, I hope that at least some of those submissions are accepted to make it a bit more fun during the closing ceremony.
Yeah, if it's all gonna be oh.
Yeah, it would be really sad. But I suspect that we will see more submissions. Like, it's more than half an hour to go. Now the teams are like, faster, faster, faster. We need to have enough time to submit it. It would be also extremely nice to see if any team that is not in the top right now would solve any of the 3 hardest problems. Like if team that is not having 9 right now would solve any of them. Because honestly speaking, I think it may be the case that you are like very good with dynamic programming, one of your teammates, and you manage to solve G before your like 2 other teammates understand that the greasy approach in B is incorrect.
Yeah.
Like theoretically that could happen.
I think out of these problems, I would say H is the most likely for this to happen, because this is a problem where I think if you're very mathematically inclined, and especially combinatorics, then this might be something you're immediately drawn to more, and so maybe some team actually persists and solves this. Even though I think for the teams in the bottom half of the scoreboard, I would very much recommend just following the teams in front, because I think there is a significant step up, and I mean you can see this if you look at the scoreboard between the first 9 and the final 3 problems. We have a large chunk of teams at 9 or 8.
Yeah, I understand, but it would be just nice to see, like, if you're not fighting for the top places, let's
Yeah.
say, then just to challenge yourself and beat one of the hardest.
No, I mean that
problems,
would
it
be
great.
super awesome. I mean, I think the first solve bragging rights are already gone for all problems save I, as far as we know at least. So I mean, yeah, and if you get a first to solve, then you will get special recognition during the awards ceremony. So yeah, I think if that were to happen, there would be giant applause in the contest hall.
Yeah, the one. Yeah, go on.
Although there are some teams, maybe not at the very top, that are still interesting to watch. For example, place 24 and 25. We've already talked a bit about Saarland University submit earlier, but I also remember Aalto University. They had some first solve yesterday, and it came a little bit out of nowhere for me because I haven't seen them in any lists really. I was just shown that they had some World Finals participations like years ago, but who knows? Maybe some of the teams a little bit below medals or just challenging medals can get one of these problems done.
Yeah, it would be nice to see somebody that were not on our radars and on our screens too often during the contest, like lift their positions up during the last hours would be great. But about the problem H, it's also I just realized that if you are a like math guy in your team and your team hasn't yet solved B, that maybe your team sent you to B, which means that you're not reading H and probably I know the data structure. So the strings guy read H and he's like, I don't know what to do here, no idea, some randomized algorithms, whatever, and yeah.
Yeah, maybe this is just me speaking, knowing the solutions. H feels much more mathematical than B to me,
Yeah, in
for
this
sure.
sense, yeah, but I mean that you need to read it and think just for a moment maybe about it to understand it. So if it was read by non-mathematical person from your team, it may be the case that he just didn't give the statement to the right person, and then it's like after during the editorial you would like, man, why didn't you give me this? Why didn't you give me this problem? So yeah.
I mean, I hope at this point we are 4.5 hours into the contest now. There was plenty of chance to read all the problems. I think it's generally advisable to read all the problems, at least at some point during the contest. Maybe if you, I mean, at this point, I think if you're in the bottom half, you don't need to bother reading I probably. But other than that, yeah, it's always, difficulty is not objective. It's very subjective sometimes.
Yeah. And all of those little moving pieces during the contest is like the things that you do know when you do training. You know that like you need to share solutions, you need to explain everything. Everybody should read all the problems that are not solved yet, etc., etc. But then during the actual contest, as soon as something goes wrong, as soon as you get some couple of wrong answers, then this strategy can go completely wrong. So yeah, it's always a fun part that something unexpected happens.
Yeah. All right, I think I should probably get going now. We still need to wrap up the solution slides, or I mean, I hope when I return to the jury room they have been wrapped up, but if not, I think it's on me to actually ensure that we will be able to present the solutions just before the scoreboard reveal and the award ceremony.
Yeah, sure. So then we will let you go. Obviously, there's a lot of more important things to do than maybe just sitting and talking just with us.
It was a very nice chat.
Thank you for coming then, and we will see you during the award ceremony probably or during the editorial. But for now, we will take a short break and we will come back soon to see how the contest ends and speculate a bit more with Jonathan. So stay tuned.
Yeah. Bye-bye.
And welcome back, everyone. So here we are, two of us, looking for the last 10 minutes of the contest, trying to figure out what is happening. We have pretty a lot of submissions right now. Everybody tries to get at least something. However, in the very, very top, only two teams try to solve problem I. One of them is the first team, the University of Cambridge Bra Open. They were first before the freeze time, as you can see right now. So just the short notice that it's optimistic scoreboard. It's not yet revealed which submissions were accepted. However, yeah, two teams tried to solve problem I. For the Hasselblatter Institute, it's a bit tricky. They still don't have G, but with I, they have a couple of submissions and like more than 30 minutes between them, so probably they fixed something. Let's hope for it. Yeah, and then just a bunch of teams trying G and H.
We've also just now, even on the optimistic scoreboard, we're seeing some movement because there are just some teams that are trying to now get anything in because one problem more is more worth than however much penalty you will get. So you just, in the end of the contest, usually submit as much as you can. Anything that has a chance of passing is going to be sent to the judges.
Yeah, and most of the teams are still fighting for like B and C problems. I think somewhere in the middle. Yeah, also the team that didn't solve anything during the contest time, they also tried to finish the L and B problems. So let's hope they manage to do it. And yeah, a lot of teams with 10. So it looks like if at least part of the submissions are accepted, we have quite a shake up in the top. You can see now that, yeah.
It's also notable, you see that there are a lot of teams that would move towards the top that were before like somewhere in the 20s, even maybe 30s in the places, if they manage to get these problems finished, which would actually be quite nice. It's G and H. I guess H in particular is also one of these problems that you can maybe just figure out where you don't need to have, where prior knowledge helps definitely a lot, but it's not required.
Yeah, for sure. We haven't discussed it in details, but yeah, it's just basically we shared, I think, the statement during the live stream, and basically, yeah, the trick is to came up with some construction from combinatorics or so that would help you to do it. So it's not about the implementation, but it's more about the idea and how to approach this problem. Yeah, and by the way, we have the team from the Constructor University of Bremen that submitted problem I, and maybe even some two teams that were not in the very, very top before that, also from the University of Amsterdam, who maybe solved problem I. I think theoretically it could be possible if you are super expert in geometry and data structures that you would prefer I over G and H, especially if you already spent some significant time on it before the freeze time. However, I would be surprised, let's put it this way, if guys who didn't solve G or H would solve I. I would rather expect that at least half of the submissions for G and H would be accepted. They were mostly done by pretty strong teams. Even they were in the 30-something place before the freeze time. It was pretty difficult to make it clean and smooth, considering problems like B and maybe E. So yeah, maybe just have unfortunate penalty.
Although I'm not quite sure, even if the first Cambridge team didn't manage to get their I through, if there right now is anyone who can challenge them just on the submitted problems.
Yeah, no one can beat them. And also the only other team that has 11 problems, they have much higher penalties. So if they both solve I, that means that it's still the same first place. Yeah, this is the normal scoreboard. If nothing is accepted, which is sand, or at least not clear. By the way, we wanted to make a small announcement that after the contest ends, we would probably run very quickly to the contest floor to grab some contestants and ask them questions how they feel, if there is anything they can tell us about the result, the problems, and overall. So stay tuned. We will make soon a short break to just quickly run there. However, for now, while we are still preparing this setup and waiting for the contest to be closer to the end, I just wanted to say, while we're still here sitting calmly in this auditorium, I wanted to say a big thanks for our team behind the scenes who are working on the live stream and switching all the nice images you are seeing. Also to the great jury team who prepared the task, to all of the volunteers, organizers, the sponsors who allowed this to happen. So, and for the university also to hosting this event. I do believe it went well. I think the problem set was fun, and we spent some great time today, this Sunday. So thanks everyone for sticking with us. You can stick for a bit more, and we will be running to the contest floor. So that's it. Thank you. amazing space with tons of teams. Some of them are probably very happy with today's performance. Some of them are probably not. We will probably grab a couple of them to see how it went and ask them what went good, what went bad. You can see that a lot of balloons all over the place, all around me. So maybe, I don't know, if we can go and ask someone how it worked. Okay, hi guys.
It could have gone better, but it was fun.
So how many did you
We did 4, and we felt pretty close to 3 others, but we never got there in the end. But
Okay. Four is decent. Those the gentleman set of problems, I would say. Yeah. Okay. Yeah. See you during the award ceremony, and we can go further somewhere to the next team. Hi guys. So how do you feel?
It feels good.
How did it went? How many of them did you get in the end?
Should we say this or should we wait until the scoreboard is unfrozen?
But if you don't want to spoil, then let it be it. Let it be the secret.
It went well. We solved 7 problems, and we met the expected what we expected, the expectance, and yeah.
What was your favorite one among them?
I liked E, even though it was hard.
Nice one. I think can go wrong, but yeah, definitely also different approaches to solve it. So, did you manage to do it?
We managed.
Yeah, we managed to solve.
Man, good for you. Good for you. Okay, guys. So see you in the award ceremony, and can we move around a bit, or I don't know if we can go somewhere else. Let's see who else we could find here. So, we have one of the coaches and crew members here. So he was one of the persons who was helping us a lot with the stream in the background. So how did it went for you today?
Hi, went great. I learned a lot about streaming, and I think my team did well.
Yeah, actually, he was the coach of the team from the Hasa Planetary Institute that did extremely well. So without spoiling, are you proud of them? You will say only good words, or anything went not ideal?
I mean, we are place 5 before the freeze, which means it's probably medals, and I'm happy.
Nice. Okay, let's go. We can show a bit of our huge contest floor, and everybody is just running around and doing something. I see some team with a lot of balloons. Let's ask them how it went. Okay, hi guys, I see you have a lot of balloons. So how did it went for you today?
It went well, but we expected to get even more.
What was the main problem among the problems for you then?
The main problem was actually we couldn't focus on a single problem, so we had solved at the end. So we should have been focused on one problem.
Yeah, that could happen, but it was the kind of a contest with a lot of both medium and hard problems. So yeah, but anyways, I see you have pretty packed balloons. So good job. See you in the award ceremony. Okay, who can we get next? Let's see if we have some more. Oh, I see one interesting team. One of the teams from the University of Cambridge. Maybe they can share something with us. How do you feel?
Very, very mad about problem G, actually.
Problem G, so...
Nasty problem to implement.
So without spoiling the results before the award ceremony, it was probably the most difficult one among them, but I saw you also tried to do I, right?
Yeah, but... Desperate attempt at the end, yeah.
Okay, I see. So we will be mostly watching if you manage to solve G or not, I suppose, yeah. But you did very well. I think the competition between Cambridge teams was quite tough.
Yeah, it's like China at the IOI.
Yeah, well, the good thing is that sometimes the places were switching, so it's not that only single team was on the top, at least the whole time. I think it was the moment when you were the like fourth team from Cambridge, then first, and again somewhere in the middle. So yeah.
Our main competition is Cambridge teams.
Okay, so but anyways, very nice job. I think that's the largest pack of balloons I've seen up until. So see you at the award ceremony, and really good job, even though if you didn't manage to do it. But anyways, you are consistently performing well today. So yeah, see you. Okay, let's move forward. Everybody's maybe team. Hi guys. Oh, it's maybe kind of noisy because somebody is destroying the balloons, but I really wanted to get somebody from organizers, from the sponsors teams. So let's go this direction. All right. Hi guys, can I bother you for a minute? How did it went for you, the wizards of the network?
It was quite good. There was not a big outage. There was never really a big outage. Just some OOM kills for the PCs, but yeah, that was fine.
So overall, no major problems. Yeah, I think you did a really great job. So thank you very much, and yeah, for this amazing setup. Any lessons?
Not really. It went as expected.
Okay, all right. Then, yep. Thank you. See you. Let's go grab. Yeah, probably we are. Everybody's running away from the decides what to expect a bit in the closing ceremony. So thanks everyone for being with us today. It was a long, not easy contest, but yep. Thanks for sticking around, and we'll see you during the award ceremony. We will wrap it up.